like what I was trying to say by citing those people. And I would say, like, again, like a great example of a Lightning operator that will do things for the ecosystem that's not custodial per se would be bolts. Are you familiar with bolts? Okay.
Okay, okay.
Another question in the back.
Yeah, can you come forward because of... So for anyone who has questions, please come here because of the distance of the microphone.
Hi, notwithstanding the fact that you don't have a time machine, do you think we're going to see the transaction volume on Lightning moving over to Arc in the coming years?
Okay, so apparently I did a really shitty job at my talk because this is exactly what I'm trying to highlight. I think we will see lots of payment volume on Arc. I think that is probably going to happen. But I think as those people either are paying amongst different Arc ecosystems, because there will be different Arc implementations, and even amongst those implementations, probably different sets of operators. Arc operators, I mean, not Lightning. As payments are happening in Arc, the protocol level, but they need to move across these different Arc implementations, that will happen on Lightning, right? So this is just the same thing as, like, if people are using, you know, Bank of America's banking app and they're also using US banks, and now they're paying each other, like, yes, they're using the bank ledger, which in this case would be Arc, but they're also using RTP, which is the sort of instant settlement layer that's connecting those banks, and that's like where Lightning will sit. So I'm saying, I'm really glad these things are being built because they complement Lightning, they don't replace it. We just need to reframe that maybe Lightning wasn't the consumer end thing we thought it was. Okay, it looks like that's time and questions. So, cool. Thank you, guys.
Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows.
Magazine to talk about medium of exchange. Please give a very warm welcome to another Michael. Thank you.
Yep. Yo, yo. Can you guys hear me? Sick, sick. All right, we good? Cool, cool. All right, how's everybody doing? Awesome, awesome. Really quick, I just want to give a special shout out to Nifty and the Bitcoin++ team for giving me the opportunity to finally speak. This is my first time speaking on a platform, so thank you, Nifty and the Bitcoin++ team, for giving me this opportunity. Sure. Thank you. I'm breathing a little heavy. We good? Cool. Awesome. All right. So really quick, my name is Michael Markle, and I like to think of myself as the medium of exchange at BTC Inc., which for those of you who are not familiar with BTC Inc., our company mission statement is very straightforward. It is to achieve hyper-Bitcoinization. And here is a breakdown of how we're trying to achieve that. Hey, do you guys have a clicker?
Yeah, but it takes a second to configure.
Okay, I don't know why it's not.
Can't advance?
Let me try it again. Hit continue. Cool. is this maybe a setting on my, oh, I wonder if it's a timer.
Oh, you're at the end, not the beginning.
Oh,
Go ahead and hit slideshow.
sweet. Cool. All right, is it working? That's okay. That's okay. I can use my computer. Okay, so those of you that aren't familiar with us, here is what we're currently building to try to help achieve hyper-Bitcoinization. So as I was saying earlier, I'm with the BTC Inc. brand, which is the parent company. And underneath that umbrella, we have some of our brands like Bitcoin Magazine, which runs our media arm, our Bitcoin Conference, which runs our event space. We also have our trade association for Bitcoin for corporations. And over the past couple of years, I've had a very interesting perspective of my job by focusing on the events. I feel very privileged to be able to travel all around the world and see what Bitcoin means to different parts of the world and how can I help bring it to life in their neck of the woods. It's really, truly an honor because you get to collaborate with so many different walks of life to see exactly what Bitcoin means to them. Aside from the conference, we also have our museum in Nashville that's going to be opening to the public really soon, so I'm really excited about that. And yeah, we just have a lot of really cool things cooking. So really quick, I'm sure a lot of you guys have seen this chart before. This comes from Nick Szabo on the concept of money. And it's been echoed by Satoshi himself and also later Hal Finney. And obviously it's just talking about how Bitcoin's probably going to evolve in stages. And before we just kind of jump into the obvious stages, does anybody understand any other concepts throughout our lifetime that may have walked a similar journey? Well, well, believe it or not, the concept of time actually walked through this similar pattern, where you started with stage one of time being a collectible, meaning it was just a sundial that was very hard to make, it was rare, and it was often used as a status symbol for the elites, whether the kings or the priests or high-ranking government officials. And then time eventually morphed into a store of knowledge with calendars and understanding cycles of astronomy and cycles of farming and even religious cycles, which then morphed into stage three, the medium of exchange aspect, with clocks. Clocks was the shared denomination for coordination across different parts of the world. You know, you had calendars that allowed for, you know, trains to meet up at certain times, for groups to assemble at certain times, for markets to open, which then eventually led to stage four, the unit of account, which is obviously hours, minutes, seconds, which allowed for global synchronization and it was later applied to internet protocols, which is obviously very important. But does anybody know how long it took for time to go from stage one to stage four? Any guesses? 3,000 years. So I do think Bitcoin is walking a similar trajectory. I think we have achieved stage one, and I think we are currently on stage two right now. But thank God we have the internet, and I do believe the internet compresses time. And I really think that we can achieve this with Bitcoin in about 30 years. So I really do believe we are at the, you know, center of this adoption journey. I think we are going from stage two to stage three. So it's going to be very interesting as we're along on this 16-year journey, what the next 16 years bring for Bitcoin. So again, I'm super excited. I think there's so much happening in the space for medium of exchange and things of that nature. And I know a lot of the conversation right now in Bitcoin has been dominated by the financialization of Bitcoin, the launch of treasury companies. But in reality, I really think when Bitcoin historians look back on this time, it's not going to be about treasury companies that are being launched. It's not going to be about core versus knots or whatever the fuck you guys are arguing about. It's going to be, what did we do as Bitcoiners to allow for practical everyday usage of Bitcoin? So again, I'm really excited for these next 15 years. Which brings me to this. So with my many hats that I have to wear at BTC Inc., one of the core things I've focused on over the past couple years is our in-person merchandise store at our events. And the reason why I'm focused on this is because at first glance, it looks pretty straightforward. You know, we're selling hats, shirts, t-shirts, magazines, books. It pretty much operates how a normal business would in maybe your favorite neighborhood. But in reality, it's actually a lot deeper than that. There's a lot going on under the hood when you start to really think, what does this merch store at the event mean to us? Does anybody notice anything in these photos? Or maybe here? Or maybe even here? Any guesses? All right, well, Bitcoiners. There's Bitcoiners here. This store represents what I think a hyper-Bitcoinized world looks like. No other event or activation do we see in today's world a mass migration of Bitcoiners coming into one spot that are somewhat knowledgeable in what Bitcoin is. They typically try to use their Bitcoin, and sometimes, with a lot of convincing, willing to spend their Bitcoin. So again, I think this is a true case study of what we can achieve in a hyper-Bitcoinized world with programmable money. So my job requires a lot of brainstorming. You know, how do I convince people to spend their Bitcoin? You know, I take my full salary in Bitcoin. I truly live on a Bitcoin standard. So I don't have a choice. I have to spend my Bitcoin whether I like it or not. So typically I ask the question, how would you like to pay today? And I start with Bitcoin, credit card, or cash. And there's nothing that irks me more or just gives me the ick when I hear a Bitcoiner be like, credit card. I don't spend my Bitcoin. I have to always remind myself to kind of level set, cool it. You know, the conference can be very chaotic. At the end of the day, our goal here is to educate. And, you know, I have to understand that 99% of the population probably still earns their salary in fiat. So I, too, would rather spend the shittier version of money. So anyways, at the end of the day, too, I think another thing we have to think about is Bitcoin is so new. I mean, this is arguably going to be the best technology of our lifetime. So at the end of the day, does any of us truly understand what it's capable of or what it can achieve? And the answer is probably not. So the people that try to tell me what Bitcoin's not, those are the people I typically shy away from. All right, so anyways, you don't want to spend your Bitcoin, you'd rather spend credit card, that's fine, I get it. But at the end of the day, I have to remind myself that I'm the store owner. So I have to bear the consequence of that fiat. And what I mean by that is there's a lot of headache that's involved when you're trying to accept fiat payments. Not only am I trying to throw events in the United States or Asia or Europe or the Middle East, any time that you try to get a fiat payment processor is the biggest pain in the ass. They want to know what you're selling. They want to know who you are. They want to know who the owners are. They want to know sometimes a breakdown of all the shareholders of the company. And it's like, fuck off. I don't have time for this. I'm selling shirts and hats, people. Like, come on, give me a break. So again, I have to constantly think, how can I incentivize our attendees to spend their Bitcoin? And an obvious, answer that comes to mind is to offer a discount. So obviously we've seen in the past, like your typical 21% off when you pay in Bitcoin. But what quickly evolved from offering a discount made me realize, in reality, I'm going to actually charge you a premium for paying in fiat because of all the headaches that it requires to get it back all into the currency we want, which is Bitcoin. Not only do I have to rely on partners and third-party payment processors and Excel spreadsheets and then verifying Excel spreadsheets and like more spreadsheets, like it's just too much. So in reality, I'm actually going to charge you a premium if you pay in fiat. So aside from the merch store, another activation that I take a lot of pride in is making sure our F&B do Bitcoin payments, which takes a ton of convincing because a lot of these conference venues, they don't want you to even mess with their F&B. So there's times in the past where I thought I had all the clearance and then the day of the event, we're not allowed to do it. So going forward, if we don't have Bitcoin payments in our F&B, like it's, I try my best to sell it, and I think continuing forward, we will always have it. But anyways, going back to incentives, so for F&B, I can't offer a discount if they pay in food with Bitcoin. So again, going back to that mindset of charging you a premium, one of the ideas that we came up with was actually putting in priority lanes at the food and beverage in the bars. So if you pay in Bitcoin, you're actually saving time instead of having to wait in the line. So again, the only thing more valuable in Bitcoin is time, and we've put incentives in place where you can skip the line and check out with Bitcoin, and you're good to go and you get to skip it. All right, so going back to the merch store, one of the things I want to hit on that I think is really cool that's operating under the hood is this idea of self-custodial payment processing. Obviously, I'm sure you guys have seen this logo, BTC Pay. It's not a company, it's just code. It's an amazing open source project in Bitcoin, and I appreciate everybody that's ever contributed to it. It's one of the core tools that we use at BTC Inc. from the top all the way down to the merch store. So anyways, what do I mean by self-custodial payment processing? Well, for the first time in humanity, we can finally do self-custodial payment processing digitally. In past life, if you wanted to operate a self-custodial payment processing business, you would have to run an all-cash business, which is obviously not practical. It is very powerful for a lot of reasons that I probably don't need to go into, but it comes with a ton of trade-off and risk. Not only do you have this risk of centralization of capital in one place that invites theft, you also have the risk of counterfeit. And you can't even expand beyond your local economy because you can't do a digital cash payment until Lightning. So we see a ton, of innovation because of this. And I think we're just scratching the surface on what's possible with self-custodial payment processing. A couple ideas that come to mind is like incentive structures for how workers get paid. We can do prism payments to where if you're selling coffee, the worker gets maybe 50 cents of every transaction instantly. So now all of a sudden they are wired to like incentivize to sell more and work harder. Another idea that comes to mind is just the simple UI on the checkout. Because it's self-custodial and it's not like, meaning there's no custody from the payment processor, there's no logins, there's no usernames. So it doesn't matter if you're the worker behind the clerk or behind the checkout counter or a customer in the store or somebody on the other side of the world that wants to buy a product for their friend at the store. Like it's all the same UI. And I just think that's so cool. And I'm really excited to see what we come up with over the next couple years. But really quick, I want to talk about the challenges as well when it comes to operating Bitcoin as a medium of exchange. So one of the biggest challenges, and it's so obvious, and it's this never-ending problem that I haven't been able to solve, is Wi-Fi. I don't think we understand how much we take Wi-Fi for granted. Like, just trying to keep these connections stable across these devices is such a pain. Because one, you just have this mass migration of people all coming into one place, and the first thing they're asking is what's the Wi-Fi password. So it creates a lot of challenge when you're trying to do payments. Like 99.9% of the time, it's not failed payments due to routing issues. It's literally Wi-Fi connection. Not to mention, sometimes we have presidents and vice presidents, at our event, which means Secret Service, and their job is to stay on top of information, and they, a lot of that involves them being tied into what's going on and really can interfere with a lot of the communication. So again, Wi-Fi is a massive problem when it comes to Bitcoin as a medium of exchange. And there's nothing more, there's no worse feeling than being in the store, convincing somebody to pay with Bitcoin, and they finally do it, and they go to their Bitcoin wallet app that's probably been sitting dormant, and they go to click it, and it automatically updates and downloads, and they end up having to pay with credit card because it's not going to download because Wi-Fi is a problem. So that made me think, okay, well, how do we expand beyond that? I believe for Bitcoin to be a medium exchange, yes, it is a digital transaction, but sometimes I truly believe it has to have an in-person component to it. And that's why I really like these bulk cards in a lot of ways. Not only is it an easy way to onboard people into Bitcoin that have maybe never experienced Bitcoin, it has a physical component to it. And in this case, on this particular one, it might be hard to see, but there's actually laser eyes that light up when the transaction's being performed. And the reason why I find that so fascinating is because I've seen firsthand parents and kids do their first Bitcoin transaction. They see that laser eye light up, and it almost hits like a dopamine effect. It's really quite remarkable. They are very drawn to it. And you got to even think a step deeper than that. A lot of the times, I even think the sounds play a major role in it. There's a pretty satisfying feeling of doing a Bitcoin payment, tapping it, hearing the coins get sent off of the device, kind of traveling through the channels of Lightning to that ping, that instant settlement ping with the graffiti and the receipt getting printed. I've literally seen people buy another item because they want to do a transaction. So I find that absolutely fascinating. And shout out to Evan here. All right. So as we continue to evolve and innovate, this brought the opportunity to collab with some pretty amazing partners this year at our conference. And I had the privilege to get to work alongside Square in announcing their Pay with Bitcoin initiative that they've been working on this year. And essentially, they are planning to roll out Bitcoin payments at all their devices, and I think their target is by end of year. So it was really cool to see them make that announcement at our event, but also have this going on live in the store. So it wasn't just like this is what we're working on, like you could try it today. And I thought that was really cool. All right, let's get into some stats. So I've been doing the payments since 2023. Our event has continued to grow. And right now, the data that I'm seeing is about a 60-40 split. And what I mean by that is about 60% of the transactions are credit card and 40% are Bitcoin. And our event continues to go up in number of attendees, so we do see more volume, we do see more transactions. So I remain relatively bullish on trying to work towards the goal of eventually eliminating fiat at our conference. So this invited so much, challenge that we decided to set out and try to attempt to break a Guinness World Record. So Guinness put forth the guidelines that you have to, we set out to achieve the most in-person Bitcoin transactions along an 8-hour time window, which we set out to achieve at Bitcoin 2025. And the rule was it had to be exchanged for a physical good, and it needed to be at least $1. So no, the Zapathons don't count. Sorry, guys. But we did end up breaking the world record at 4,183 transactions, and that plaque is currently displayed in the Bitcoin Museum in Nashville. But I will be the first to hand it off to the next organizer that steps up to the challenge to continue to try to push Bitcoin as a medium of exchange forward. So one last note that I want to hit on, I look around this room and I clearly get the sense this is a very, very high signal event. I see a lot of Bitcoiners in here that are very well versed in Bitcoin, and I'm excited to see the presentations and projects you guys are working on, and hopefully the opportunity to collab, because I'm not a developer at the end of the day. I'm just trying to apply the tools that you guys build to make sure BTC Inc. runs efficiently on a Bitcoin standard using open source tech. And I just wanted to say one last thing, again, I know this is a very high signal event. I invite all of you to come to our event and participate to help us push Bitcoin as a medium of exchange forward. And I know a lot of the critics in here would say our event has maybe too much noise at times, and maybe I would agree with you. But hey, sometimes you need a little noise to find the signal. So thank you, everybody.
Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin.
Back to the main stage here at Bitcoin Lightning Electric Edition. I have Roland Buick from Alby to tell you more about the intersection of Bitcoin and AI. Please give a very warm welcome to Roland Buick. Thank you.
Hey everyone, I'm Roland. I work on Alby. For those of you who don't know, we basically create products, tools, services to make it easier for everyday people and businesses to use the Lightning Network. So the first one is Alby Hub, which is your wallet that you can connect to any app, both in the real world, any device environment. And also we have the Alby extension, which you can plug into the browser and connect to any Lightning-enabled website. And Alby Go is when you go in the real world and scan and make payments. It's the simplest app you can think of it, similar to Wallet of Satoshi, but it's fully self-custodial, connected to Alby Hub. And Alby MCP, which I'll talk about later, is our new AI product, which allows you to give Bitcoin abilities to your AI agents. So the real cool thing here is that all of our products are fully open source, and we help support open protocols, and the products that we actually build are all powered by these open protocols. So this is kind of our vision for Lightning. You have Alby Hub in the center, which is your Lightning wallet, your self-custodial open source Lightning wallet, and it's connected to all the apps that you use on a daily basis. So connect to the Alby extension to use Lightning on Stack & Use or in Nostr apps, and also connect to Alby Go to make payments in the real world. And just with one additional bridge, we can enable Alby Hub to power agents to make and receive Bitcoin payments. So I'm going to make a few predictions here today about what Bitcoin and AI will look like 5 years from now. So, of course, this has to be a given, right? That there will be more native Bitcoin use. What I mean here is more businesses accepting Lightning, more end users using Lightning. And another thing, most people today on their phone, they have many apps, 50 apps, 100 apps. And every time you install a new app, you have to learn about the interface, you have to learn how to navigate the application. But what I think will happen is that instead you will most commonly just use an agent app. It's familiar for users, they already understand the interface, and the agent can do everything it needs to do for the user. And of course, agents could use fiat currency or stablecoins, but I believe they will use Bitcoin as the permissionless currency. It cannot be rolled back, it cannot be stopped, instant settlement. And also because agents, as we have seen, are powered by open protocols actually. Open source has been winning here. So I don't think it makes sense that an agent will use closed source money when everything else is open source. And this might be a wild one, but I think Nostra will facilitate these payments because Nostra is actually perfect for Bitcoin and AI. It's machine readable already. It's just public data, JSON data. There's no middleman. There's no lockdown. Everything is free for agents to use. And we can think about apps like Airbnb or User, right? Uber Eats. Right now, you have this middleman, and they always take a cut of every transaction, right? But with Nostra, we could actually create a fully open source version of Airbnb or Uber Eats or any of these platforms that facilitate this purchases. And users could actually use their web of trust to know that when they order a pizza, the delivery person is actually going to deliver the pizza, and that the restaurant is actually a good restaurant. All of this can be done through Nostra Web of Trust. So what are some Bitcoin and AI use cases today and in the future? First, of course, we've seen that a lot of people are using AI for developing code, creating images and videos. Right now, people normally use their credit card or they buy tokens in advance. So we could actually use Bitcoin Lightning payments here instead, which gives a few advantages like instant settlement, micropayments you pay just for what you need. You don't have to buy a lot of credits in advance. Which I kind of briefly mentioned, I think is a really cool idea about agents, is that I can ask, for example, book me a trip to Berlin, right? And it would find the plane tickets if I would need, it would find hotels if I need them, it would make these payments in Bitcoin, it would do everything for me. So when I came to Berlin, I normally live in Thailand, I actually used both Travala and Bitrefill. So Travala I used for booking my hotels on the way here, and also the flights, which is really cool. So I think the next step for Travala, which is like a web interface, it's a closed service. Actually, if it integrates with agents, then directly in your agent you can just say, book me a trip to Berlin, and it will do it. I think that's great. So I also use Bitrefill to buy my eSIM. And I think Bitrefill is actually leading the way. I'll talk about it later. But you can directly connect your agents to Bitrefill, buy gift cards. For example, I bought a grocery store gift card, and then in real life I go and buy my groceries basically using Bitcoin, which is really cool. So the next thing is we give agents all these tools to do things that we would normally do to make our lives easier. And some of these services actually cost money. So if we give an agent access to a wallet, then it can pay for other paid services in order to fulfill the requests that we need to make. And the last one I think is a bit interesting, right? That you can give an agent certain instructions, maybe certain topics, and then it will take that information. Maybe you give it some money, and it will try and actually grow and earn more money from your initial investment. So there's a few like this already. We have to see if they work out or not. So the question is, how do we actually connect agents with Bitcoin, right? So an AI agent, maybe put your hands up. Have you used ChatGPT, Claude, any of these? Yeah, basically everyone. So this is what an agent looks like without any tools, right? So it's like me, I'm in an empty room, I'm sitting at a table, I only have a pen and a piece of paper. But if we give agents tools, basically the sky is the limit in what they can do. And the whole idea about this is there's this open protocol called MCP that allows agents to gives agents access to these different tools over a common protocol. So it could send an email or create a calendar entry, for example. And you can kind of think of it as like the USB-C. So any agent can connect to all these different tools just over a common interface. So the really cool thing here is, like, why did open source win for agents? Why do we have this open protocol for different models, right? Claude, ChatGPT, all of these. So the really cool thing is it fixes this n times n problem. Basically, a developer can create a tool, and no matter what agent you use, no matter what model you use, you can use the same tool. And before MCP is the open protocol, you would have to create a different tool for every single agent platform, which is not sustainable. And also, as a user, like if you want to change a model from Claude Sonnet to ChatGPT, all you need to do is change one line of code. Everything just works, right? And this is the really cool thing. It's fully interoperable and portable. And MCP this protocol is super simple. It's basically, give me a list of tools. I want to use one of these tools. You send a request for this tool, and you get a response back. And it's just all in human readable JSON. So back to Bitcoin, right? How do we connect Bitcoin to agents? How do we create an MCP server, this tool that will allow your agent to use a Lightning wallet, a Bitcoin wallet? But actually, that's the wrong question, right? Because as we saw before, MCP is this open protocol. Now we don't want to create a specific connection to a specific wallet. What we actually need is an open protocol. And this open protocol is called Nostr Wallet Connect. Basically, it allows you to connect any application to any Lightning wallet over a common protocol. It abstracts all the differences away from the different Lightning wallet implementations, like LND, Core Lightning, Wallet of Satoshi, CoinOS, Blink. All of these have their own APIs, and they're not compatible. But NWC on top abstracts that all away. Developers only need to use NWC to connect to any type of Lightning wallet. So how it works is we have this seamless connection, and it's powered by a Nostr relay. And Nostr Wallet Connect is actually very similar to MCP, this open agent protocol. But instead of connecting agents to tools, it's connecting apps to Lightning wallets and nodes. And the cool thing here is, even though it's called Nostr Wallet Connect, it's just, under the hood, that's how it works. But end users do not need to understand how Nostr works. It's just like sending an email. You don't need to know how these protocols work, like SMTP. And as I mentioned, this is super simple for developers because they only need to write code once and they connect to all these different type of Lightning wallets. So how does it work? We have the app on the left-hand side, and this could be an AI agent, it could be a Nostr client, it could be the Alby extension, Alby Go, anything, and basically it wants to communicate with your Lightning wallet. So what it will do is it will send an encrypted request over a Nostr relay, and your wallet will subscribe to messages from this relay. It receives this request, and then it executes the functionality. So here we send a payment to the recipient. And so far in the last 2 years since Nostr Wallet Connect has come about, there's been huge adoption from wallets, payment tools, social media, Nostr clients, for example, Stack and News, exchanges, Lightning backends, games, AI and automation now, communities, and a whole bunch of developer tools and libraries. So it's really expanded over the last few years, and it's becoming the number one way. It already is the number one way to connect an application or an agent to your Lightning wallet. So how does NWC work with AI? The great things around this, as I said, an AI agent, you can just think of it as another application you connect your Lightning wallet to. And the great thing here is that as an open protocol, AI agents using a single MCP server can access to any Lightning wallet that supports NWC. And we can also restrict the access that agent has to your money. We can give it a budget of 10,000 sats a month, even 1,000 sats per day. It's entirely up to you. And not just that, you can restrict what methods it can actually call. So maybe it can only receive payments, it can't send payments. Or it can only be notified when you actually receive payments. Like if you have like a light bulb that, a zap lamp that lights up every time you receive a payment. All these ideas are possible. Another thing you can do is you can create sub-wallets inside your actual wallet. And this basically isolates your agent or your app's activity inside your Lightning wallet. It has its own transaction list, and you can see if it's received or sent more overall. And the really cool thing is your agent has 24/7 access to your wallet, as long as your wallet is always online. NWC is a persistent connection protocol. So Alby has created an MCP server to be able to connect your agent to any Lightning wallet. Not just an Alby wallet, but any wallet that supports Nostr Wallet Connect. So CoinOS, Primal, there's a huge number. And the first thing, just with a few clicks, you can copy a connection into your agent and get started. And our agent doesn't just do sending payments, but it also supports LNURL. So I will show a demo later. But you can, for example, fetch invoices from Lightning addresses, and you can do fiat to Bitcoin conversion and some other things as well. And this MCP server, because it's built on open protocols, it can work with any type of agent. So Claude, Goose, Cursor, Klein, and there's heaps of them. So how does the Alby MCP server look? Basically, it gives us a list of tools that we can use. For example, making an invoice, paying an invoice, converting fiat to sats, and so forth. And we both have our hosted version and a one where you can install locally into your agent and run it. And as I said, this MCP server is just basically another Nostr Wallet Connect app. It has some permission to access your Lightning wallet, which you have full control over. So now I'll show a few examples of how this looks like. So a popular open source agent is Goose. And I'll do a very simple example. So I've connected my Lightning wallet to Goose, and through natural language, I can just say, what's my balance? And it will do this get balance call and return the balance, which is super basic. But now I can do another one, which I'll say pay $1 to Renee, my friend Renee, with the message, hi Roland, using Goose. And actually, this doesn't just use a Lightning wallet MCP server, it also uses a memory MCP server. Because I'm telling the agent, pay Renee. Who is Renee, right? The agent doesn't know. But what I can do is basically create a contact list with this memory MCP server. So next time when I chat with the agent, it can query Renee, okay, I know that Renee has this Lightning address. And the next thing, I'm paying $1 to Renee, right? But I'm paying in Bitcoin, it should be in sats. So we have this tool where we can convert. First, the agent will use this tool to get the USD, the sat value from $1 USD. And then the next thing it will do is actually request an invoice from Renee's Lightning address. And you can see Goose is actually asking me if it's okay to do these things. Every time, every single tool, the user has full control. You can say, I'll allow it once, or you can say, I will always allow it. So for simple things where it's not actually spending money, you can say always allow, right? In the pay invoice case, I just kept it as allow so that I have to every single time confirm the payment. So after this, my agent has sent $1 to Renee. And this is another cool example, actually, which uses both the Alby MCP server and another MCP server that generates a PDF file from Markdown. And this generator actually costs money in Bitcoin to use. So when you try and do this conversion first, it will say, no, actually, please pay me first. So then it will use the Alby MCP server. The agent will use the Alby MCP server to pay this Markdown MCP server, and then the conversion will proceed. Here's another one. BitRefill has their own MCP server, which is really cool. So you have your agent, you connect both BitRefill and your Lightning wallet, and then you can buy gift cards, and I think soon eSIMs as well. So I could have almost actually just used my agent to buy my, my flights, my hotels, my eSIM, everything I need, just with a single sentence. I think this is really cool. So here, what it's doing is I just ask for a €1 gift card. It will search for the one that I specified, Google Play. It finds the gift card, and then it creates an order. And inside that order, it will have a Lightning invoice, which we pay with the Alby MCP server. No matter what Lightning wallet we use, it all works the same. And then we basically get this gift card purchased from BitRefill. So there's other use cases for using this MCP server. You can use it with any type of agent. And one that's very popular is called N8N, which is like a no-code workflow generator. So it's basically you put different pieces together and this workflow will go. And the very simplest one we have here is that a user who is using your service, they can send a chat message. And your AI agent is connected to one MCP server, which is your Lightning wallet. So with that, you can just, again, chat and say, what's my balance, or so forth. But I think the really interesting thing here is when you connect multiple tools together, right? So you have your Lightning wallet, but you also have these other paid tools. And your AI agent can use your Lightning wallet to pay for, to get some premium weather data or to send an SMS to someone. These things cost money, and your agent needs to be able to spend money in order to use them. So how to install Alby MCP? First, you need a Lightning wallet that supports Nostr Wallet Connect. And I think there's like 10 or 20 wallets so far that support Lightning wallets. It support Nostr Wallet Connect. It's completely up to you. And you just need a connection secret, which you can give to your agent. And then you just install the MCP server as normal, as you've done with other tools that you connect to your AI agent. And your Nostr Wallet connection is basically the way it authenticates to be able to chat with your wallet and say send a payment or make an invoice or do something like that. So now we have the MCP server that gives the ability for your AI agents to spend Bitcoin, right? So they're fully Bitcoin native. But now we actually want to make these use cases where developers can create paid tools. And then the agent can use these paid tools by spending Bitcoin. So Alby has created another a developer library, basically called Paid MCP. And I'll give a simple example of this. So we can ask, what's the weather in Berlin? And we're using this premium weather service, so it costs money to in order to use it. So when we ask this, rather than returning the weather, it will say, please pay this invoice first. So we allow the payment, we pay the invoice, and then we do the request again. And this time we get the temperature, we get the weather back. So how does this work behind the scenes? One, we use the agent requests the tool usage just as normal. If it's a free tool or a paid tool, it doesn't actually know. But then instead of returning normal tool output, the MCP server that someone has created will actually return a Lightning invoice and say, please pay this Lightning invoice before you can use our service. So the agent it's connected to your Lightning wallet through the Alby MCP server, so it can actually make this payment to this other tool. And then this time, we can do the request again, the original one we did. And this time, we provide the hash of the payment we did, and then on the tool side, it can check, one, that the payment was actually made, and two, that this payment has not been used yet. So maybe you can only, for every payment, you can only do one request to the weather service, for example. So yeah, I mentioned that already. So how do you get started for the developers here who want to build paid MCP tools? So if you already have an MCP server, just with a few lines of code, you can change it into a paid MCP server. And we also have a paid MCP boilerplate where you can get started straight away. So when you have a paid MCP server, it needs some way to earn money, right? So when someone requests a tool usage, you have to be able to return a Lightning invoice. So we need to connect the MCP server to a Lightning wallet. And the last thing you need to do is register a paid tool. So you can figure how much it costs to use a certain tool. So we can compare the original, this is the standard SDK for developing MCP servers by the Model Context Protocol developers. And with just a simple change, we can change it to a paid tool. And basically, we add one additional function that, based on the request, we can choose how much to charge the user, and we can set a description as well for the invoice. So I think now Alby has built these parts, and the foundation is there. Developers can create these use cases. So I think the next few years are going to be pretty interesting. So if anyone has any questions, let me know.
Anybody questions? Hey, great talk. I'm curious if you looked into any of the other recently announced AI payment agent protocols by the different AI companies. It seems like a couple weeks ago there was a big wave of new protocols being announced. Is there any of those that seem interesting to Bitcoin or architecturally, or are they just strictly competition?
One thing we think is really important is a really simple protocol, and I think what most of these other protocols are trying to do is support stablecoins, support all these different currencies, and all this creates additional friction, additional complexity. So what we do with MCP is Lightning native. It's very simple. It only supports Bitcoin. So I think this in the future is going to be the winning protocol just because it's simple.
Cool. Thank you.
Any more questions?
Cool.
Okay.
Okay. Thank you very much.
Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is up.
Welcome back to the main stage. Up next we have the CTO from Fairgate, Sergio Lerner, presenting his talk, Building Secure and Watchtower Efficient Bitcoin Payment Channels with BitVMX. Please give a very warm welcome to Sergio Lerner. Thank you very much.
Working? Okay, great. Thanks for having me here in this conference. Okay, so I'm Sergio. I'm the CTO of Fairgate. I'm also the co-creator of the Rootstock Bitcoin sidechain, the first Bitcoin sidechain. I've been a long time here in the Bitcoin community. Today, I'm going to talk about payment channels, which is not my daily topic that I work on, but it's very similar to the technologies that I'm working on. So I may not use the Lightning Network language that you use, but basically it's the same ideas expressed differently, okay? And since I'm working on BitVM and BitVMX type of protocols that are also fraud-proof protocols, you will see that I'm bringing a fresh look, a new look into the payment channel problem in Bitcoin. So the agenda for today, first, I'm going to briefly explain why we need payment channels. Obviously, many of us here knows about this well, but maybe we have newcomers. And then I explain the evolution of payment channels until the Lightning Network payment channel. And to introduce these new types of payment channels, I'm going to introduce one-time signatures on Bitcoin, and then the one-time signature payment channel, which is a completely new construction. Then I'm going to introduce BitVMX very fast, and then I will show you how these one-time signature payment channels can be transformed into a BitVMX-based payment channels. And that's the idea. So why we need payment channels? Because Bitcoin transactions are slow, they take more than 10 minutes, and also we have limited space on the Bitcoin blockchain. And so if we want to do high frequency payments or everyday DeFi or everyday payments, then obviously we need a layer 2. And so payment channels allows two parties to exchange as many payments as they want, and with the security that they are settling on Bitcoin. So using this fraud-proof mechanism, and as long as the challenge window is long enough so that there cannot be any censorship, we have Bitcoin security. Okay, so we can perform thousands of millions of payments between two parties, and actually settle with one transaction on Bitcoin, and then we can combine payment channels to create a Lightning Network. Okay. So it all started with Nakamoto himself. He proposed an idea to create a payment channel Basically, Satoshi's idea was incrementing the end sequence field of each transaction and sending that to the memory pool. And kind of he thought that the last of this transaction will be the one picked by the miners, which is obviously very fragile. Miners couldn't pick any of these transactions, so it didn't work in practice. And also, it had a problem of transaction malleability. And then we had these Spielman-style unidirectional payment channels, which solved the problem of mempool. Basically, they are enforced with consensus rules, but yet they are unidirectional, and they have a expiry time, so you can use it until a specific time. So they are obviously have some limitations. And then when we had this check log time verify opcode in Bitcoin, we could create a variant of Spielman channels using this opcode, which eliminates the problem of transaction malleability. Well, then we have the ones that are more in use today. The duplex construction by Decker and Wanterhofer. It's the first bidirectional one, and it uses two unidirectional channels connected with an invalidation tree. And it's good because it's bidirectional, but the problem is that there's a lot of complexity with handling this invalidation tree, and also it has a finite number of updates that you can do because you have to bring forward the expiry time. And we arrived to the channel we use today. This is the Poon Draija, where funds are locked in out of two multi-signature, and it's bidirectional. It uses hash time lock contracts to power the Lightning Network and to connect several of these channels together. But it's very complex. I think I used to be a very kind of an expert on this topic 5 years ago, and I am not anymore. Which means that information fades very quickly because it's a complex protocol, and you have to be, in a daily basis working with a Lightning Network node to be able to have full knowledge of all these bolt and beeps and everything that is happening there. Well, there was a new design which is called L2, and that has very interesting properties. It provides efficient watchtowers. One of the problems with the previous design is that Watchtower had to store a lot of information. So maybe if there's an enterprise watchtower, that's no problem because they can, have a terabyte of space. But if you want to hire more cheap or more decentralized watchtowers, then it becomes a problem. Well, this construction requires a soft fork in Bitcoin, either any prev-out Zcash or no input Zcash, so it's not possible today. And there was a paper, and this one I found just last week, that is called Outpost, that provides a watchtower efficient payment channels. It's kind of a modification of the Pound construction. And it's funny because it requires that every state commitment stores the revocation message for the next commitment, encrypted in that commitment. So it works by storing that transaction data on an op return, and it consumes about 300 bytes, which is funny because with these changes on Bitcoin Core, we could enable, for instance, this protocol to work very efficiently. And the only drawback is that it requires, in case of unilateral exit, you have to publish this blob of information on chain, which consumes over 1,000 weight units. But today I'm bringing you two new payment channels designs, which I think are much better what we have in existence now. One is based on one-time signatures, and these one-time signatures became very popular with the BitVM protocol because it was the first protocol who relies heavily on one-time signatures for the input. But this construction is, separate from that, separate from BitVM. It's very simple. I hope you will understand it in just one slide. It's watchtower efficiency and provide watchtower privacy, which is something that none of the other protocols really provide. And the drawback is that in the case of unilateral exit, you need to spend more than 700 weight units, which is not a lot. And in the case of a dispute on the unilateral exit, then another 750 weight units. And then I'm going to show you how you can transform these one-time signature payment channels into a BitVMX power payment channels, which gives you a lot more programmability on the payment channel at a certain cost. So first of all, what are these one-time signatures that I'm talking about? This is a very old cryptographic construction. It dates to, I think, the 80s or the 70s. So basically, it's like public key cryptography. You have a public key and a private key. You have a key generation primitive, a signing primitive, and a verification primitive. This is all normal. The only thing here is that you can use only the public and private key once. And if you try to use another time, then you break the security and message signatures can be forked. Okay, so you have to make sure that you use it only once. And the other problem is that you are going to sign bits of information. Like if you take a long message, you will have to sign every single bit or group the message into nibbles or something and sign them separately. So the size of the signature is not constant, but it grows with the number of the size of the message, okay? So I'll give you an example that works on Bitcoin today and you can use for any script. So basically creating a 1-bit Lamport signature is creating 2 hashes, Q0 and Q1. Obviously you have to first create the pre-images, P0 and P1. And you hash them, you get Q0 and Q1, and you publish Q0 and Q1. That's your public key. And when you want to sign the message, you just reveal one of these pre-images, either P0 or P1. And to verify that, you take the message. If it's 1, then you check that the P that you receive hash is Q1. And if it's a 0, you do the opposite and check it if hash, it gives you Q0. So very simple stuff. And when we implement this on Bitcoin script, you get a pretty small program, but remember that this is just to verify a 1-bit signature. Okay, so this is 32 weight units per bit, which means that if I want to sign a 32-bit number, for instance, it takes more than 500 virtual bytes. So it's kind of 3 standard transactions or maybe 4 standard transactions just to sign 32 bits. But since we are going to be signing only 32 bits, it's pretty practical. And there are more optimized schemes that we are using in BitVMX and BitVM. It's Winternitz is one of these schemes. It gets you to 1/3 of this size, so you can use that and optimize it. I'm not going to go into the details here. So what are these one-time signatures-based payment channels? So this is the idea. This is the whole thing. This is the whole graph. Okay. So there are a number of transactions. Most of them you have to sign every time you do a channel update. But essentially, there are 3 of them which set up or commit to the balance at a specific state. These are the start transaction, the assert transaction, and the pay transaction. So basically, in the start transaction, what you will do is the following. Each one of the updates has a precise, a unique sequence number. So in the start transaction, this is the 3 transactions you will build each time you are doing a state update, okay? 3 new transactions every time you want to do a state update. So in the first one, the start transaction, you basically force the assert transaction to sign with your own time signature the sequence number. So in start sub I, basically I force the assert sub I to sign I. So pretty simple. And in the pay transaction sub I, basically I just pay to the 2 payment channel owners according to their balances in that state. Okay? So just forcing you to sign with the one-time signatures the sequence number of your commitment. That's very simple. But then you have 3 or 1 per party transactions that allows the party to revoke any attempt to sign a previous sequence number. So I call them revoke Alice all states and revoke Bob all states. So each time you do a new state commitment, you create a new revoke Alice all state, a new revoke Bob's all state, which has the following logic. If you give me a sequence number J, which is below I, so in the revoke transaction sub I check that I force you to give me a sequence number J signed by the other party, and if you can provide that signature, I just take all the funds. Okay, so the Alice wins and Bob win transactions there basically they provide the J signed with the sequence with one-time signatures, and they take the funds. Okay, so this is everything. There are some timeouts involved in the middle. Like, what if I publish the start transaction and I do not publish the assert transaction? Well, there are some punishment transactions that are the timeout for Bob and timeout for Alice, and I use a secret, a pre-made secret, to decide which of these two timeouts is going to be active. So the party who issues the start transaction also has to reveal a secret, PA or PB, which is hashed to two known values. And so the one that is provided allows the other to start the timeout. And of course, the other is not a variable. So it's everything. And the good thing is that we can have a different revoke transactions that we can give to the Watchtowers. This is the Watchtower B, the Bob Watchtower revoke Alice all states. And we can tie that to a Bob and Watchtower wins transaction that actually split the funds differently. For instance, it can give a part of the funds directly to the Watchtower. So the Watchtower can have an incentive, direct incentive, to issue that transaction. And then we will see how we can all make this private. Okay, what's the setup? Very simple. First, the two parties, each one of them chooses pre-mage, PA, and PB. These are only for the timeouts. Then each one of the parties chooses a secret one-time key and a one-time keeper, the key A and key B public keys, and these are sent to each other party. Then they both create and issue on-chain the setup transaction, which is basically a transaction that locks the funds. And they will also create two first versions of the pay, assert and start transaction, the pay 0, assert 0, and start 0, which basically distribute the funds according to the original balance when the payment channel was created, the setup. Okay, and this is done. So let's zoom in and see what happens when we need to do a state update. So state updates are very simple. First, we sign all transactions that I showed you except for the start and the revoke transactions. Why we can sign them and this has no implication is because they depend on the start and revoke transactions, so nothing wrong can happen if we sign them. When I say sign them, I mean two-party signature, either with multi-signature or music2, so they are protected like covenants, right? It's two parties agree that these are the transactions of the protocol. But then we have to be very careful on the order we sign these other three transactions. So first, what happens is that Bob will sign, I put a circle there with Bob's color. Bob will sign the start transaction. So now Alice has a little bit more power. Alice can decide to unilaterally exit with the state I-1 or the state I, because she has her own, she can sign the start transaction. But since we are modeling here a payment from Alice to Bob, the order I'm giving you is the order that protects both of them. So Alice does not get any advantage for publishing the latest state because he's paying Bob. So the second thing that happens is that Bob signs the revoke Alice all state transaction. So at that point, Alice cannot use the old state because she's by that. Sorry, Alice signs the revoke Alice all state. Then Bob signs the start transaction, and at that time, so Alice, I missed the color, I switched the colors. Alice signed the start transaction, and at that point in time, both of them could use the start transaction, and finally, Bob signs the revoke Bob all states. You can see that there is no middle state where any party has any advantage. And the order is established so that Alice is paying to Bob. Okay. So what happens with the penalization? How does penalization work? So let's say that Alice wants to unilaterally exit with a state that is state J, which is the state number 50, while the current state is the state number 100. So she will publish on chain the start transaction, and then a timer starts, a timeout, so she must issue the assert transaction. And when she signs this value J with the key A, basically she's done because she's going to be punished. Okay, so at that time, Bob comes, takes the latest revoke Alice all state transaction, and this is transaction of state 100. Bob does not need to store any other previous transaction, and publish this on chain, and then with Alice's signature of the value J, he just issue the Bob wins transaction and takes all the funds. Very simple, okay? We can do obviously HTLCs, hash time lock contracts. I think this is even more simple than in Lightning because there's only 2 paths per HTLC. There is no relative time locked path. So basically, each one LTLC will be a new output of the pay transaction that we create. And each of these outputs, obviously depending on the order, will have a hash lock spend and an absolute time lock spend, which must obviously reflect the timeout that the 2 parties set up off chain for that particular payment, right? And so if the pay transaction is issued on chain, then each of the parties can take the HLCs that correspond to him or that needs to collect, and everything works. Closing the channel is very easy. You have the cooperative close where basically 2 parties sign a transaction that just distribute the funds out of the setup transaction, so it's very cheap. And when there is an unilateral close that is not disputed, and then the party issues the start transaction and the assert transaction of the latest state, they wait until the dispute period is over, and they issue the pay transaction, and it's all on chain. So these are only 3 very small transactions. There is no need to, and then obviously if there are any other funds to collect from the HLCs, they can do it at that time. So what is interesting about this construction? It gives you a lot of possibilities to improve Watchtower, for instance. So first of all, Watchtowers only need these 2 transactions for each new state, and they can throw away everything before that. So they only need, in fact, if we are not going to distribute the funds specifically to Watchtowers with the Bob and Watchtower B wins, then you don't even need to give it. But let's suppose you need it. So only 2 transactions is all they need. You could even encrypt this transaction with a secret that is revealed in the commit transaction. In the start transaction, you can create 1 new secret for each commitment, for each start transaction, so that every time you have a unilateral exit, you provide the decryption key so that the Watchtower can decrypt it. That gives the Watchtower no information about what it's watching for, which is good. And so basically with this construction, you can hide the update rate. This is optional. You could even hide it from the Watchtower and do not give the Watchtower any channel ID. And the Watchtower obviously had to monitor every single start transaction that sees, but you could do it. And the channel ID, you can hide it from the Watchtower, and you will also hide the amount for all the updates except for the one that goes on chain, except for the one that is actually disputed on chain. So the Watchtower does not know, not even the amounts. So this is good. So a summary of what we've seen until now: there is a new type of payment channel. It requires only constant space, but Watchtowers, they need to store very small amount of information, like 2 kilobytes. This means that also the participant needs to store very low amount of information, because the participants are Watchtowers themselves. So each participant needs almost no memory at all. There is no need for Bitcoin softwares, because one-time signatures we couldn't do today, even if we could obviously improve it with many of the proposed new opcodes. We have this full Watchtower privacy, and we support HTLCs. So if we had 2 parties on the Lightning Network using this protocol between them, then basically they will be 100% compatible with the Lightning Network. But of course, you need both peers on both sides to be using this protocol. So I have very little time. I'm going to explain what is BitVMX and what BitVMX can bring into this. So BitVMX is a virtual CPU that you can verify on Bitcoin using a verification game. It allows you to execute arbitrary numbers of steps of chain, and you only need to perform on chain a number of operations that is in the logarithm of the number of steps you execute off chain. And we are implementing a virtual RISC-V CPU, so it's very standard, and you can program that with Rust or with C++. And the whole thing was invented, BitVM was invented by Robin Linus in 2023. You probably heard about this. The BitVMX platform was created by a joint effort of Rostock Labs, Fairgate Labs, and then Cardano also participated. And how does this work in a nutshell? So first, the prover will post an authenticated program input on chain in case of dispute. When I say authenticated, I mean OTS signed, because we don't have the opcode checksum from stack, so we have to use one-time signatures. So the verifier takes this input and locally his own computer runs it through the virtual CPU and creates what's called execution trace. I don't know if you are coders and you probably had to debug something at the assembler level, and you see, each one of the opcodes and the outputs. Well, this is the execution trace. This execution trace is converted into a hash chain, which includes each one of the trace items. And then the prover and the verifier engage in a verification game on chain, bisecting this chain, trying to find, the malfunction point. The point where the verifier notes that there is an instruction executed that has a correct output followed by an instruction that is incorrect. Okay, so at that point they have to decide what to do. So the challenger would probably ask the prover more information about that specific step, which memory addresses it accessed, what I don't know, register is using, the opcode in particular, and it also happens on chain, and then the challenger will challenge one of these properties. So like either the hash chain is broken, or the memory access is incorrect, or the opcode execution is incorrect. Any of the three things can be a cause to a malfunction. And then the challenger, with this information, goes on chain, and a Bitcoin script. There is one Bitcoin script for each one of the potential opcodes, the RISC-V opcodes. We'll take all these arguments that are signed by the other party, the counterparty, and we'll decide where to give the funds to. Okay, so I think it's pretty simple. This is how the hash chain is created. So we use Blake 3, and we have the previous step hash, and we combine it with the trace. We get a new step hash. On chain, what actually happens is a sequence of transactions, very simple transaction graph, where in the first the prover provide mid states of the computation. We don't do binary search, but a partition of the whole mid-state space. So you get a lot of mid-state, like 8 mid-states, and then the verifier chooses one interval between 2 mid-states, and then the prover expands that interval and gives you more mid-states until they find the instruction. For instance, this is an example of a binary search, which is not what we actually do, but it shows how you can iterate between a malfunction point, which always the last state is invalid, because if not, you wouldn't be challenging, until you get to the point where you have one correct instruction followed by an incorrect instruction. Okay, so how can we improve payment channels with BitVMX? First of all, instead of having a specific logic tied to Bitcoin script regarding how to revoke previous state, we can just sign a message that says, we revoke all state prior I. Okay, that's the message. And we sign it with Schnorr signatures, because we have a program that is able to check Schnorr signatures. So Alice will sign it with the SA, and Bob will sign it with the signature. Sorry, will produce a signature SB. And this is the protocol. It looks very similar to the one previously. I only added the dispute channels after the revoke transactions. So the revoke transactions are only providing the input to the dispute channels. The dispute channels have all the logic that I told you about, the exchange of messages is all there. And we add to these revoke transactions the signatures of this revoke message. So we could do anything there, like verify BLS signatures or Schnorr signatures, whatever. So the only 3 changes that I made was adding the dispute channels. We need 2 additional one-time keys. because we need to double sign these inputs. Like Bob and Alice both need to sign them, so there is a new pair there specifically for that. We cannot reuse the other because they are one time. And we add these two signatures, SA and SP, and that's all. We can do the same with the hash time lock contracts, and we can add a dispute channel for each one of them. So basically, instead of using a hash, which has some privacy implications, one of the problems of this, the existing construction, is that when there is a dispute and it all goes on chain, then anyone can trace, connect all the channels and see who paid who, at least in a pseudonymity way, right? And with this, we can hide it. We can do things similar to point-time lock contracts because we have a full program that evaluates this. For instance, we can use an elliptic curve discrete log hash function. So we can, by multiplying each point with a random factor, we can separate the on-chain transactions and make them completely untraceable. Okay, so this is another benefit. So to summarize, because I'm running out of time, we have a new payment type which is more powerful, also requires constant space from the watchtowers, and it supports more privacy, I would say, and more programmability. This is not the end of the story. The BitVMX platform currently supports one protocol, but we are working on using garbled circuits. We have we are in the middle of a research on using garbled circuits directly on Bitcoin, and so that will reduce the cost of disputes. Currently, to dispute a Schnorr signature, it takes about, this is an estimation based on the last time I checked transaction fees, like $80 transaction to a single dispute, which for large payment channels, no problem. But if you are creating very small amount of payment channels, obviously it's not good. But we can lower this to about $16 per dispute using garbled circuits. Okay, so our estimation is that verifying, for instance, a Schnorr signature, it takes 7 million gates, which is completely practical with our current implementation of garbled circuits. And BitVMX started being just the protocol, the CPU, but now it's a lot more, has many different components, and for each one of them there is a paper that has been published. So we have the CPU, we have the garbled circuits implementation that we are in the middle of it. We have the Flex protocol that allows you to put more funds dynamically on demand on any dispute, so that you can hire the bar for that dispute. So dynamically add more funds for a specific dispute. And that allows us to create, for instance, Battle Protocol, which allows to create a committee of 1,000 challengers, and for any one of the provers be able to dispute, to defend an assertion in front of, against 1,000 challengers with a fixed amount of security bond. Does not depend on the number of challengers. That creates, the possibility to create much more decentralized protocols. So I'm reaching the end of the presentation. So to summarize everything, just created and show you two new types of payment channels. These are, you could, the OTS one, it's very practical. I mean, you could implement this for a hackathon if you want it. I have not implemented myself, so feel free to create a first implementation of these payment channels. And they support efficiency and private watchtowers, and also support root hiding mechanisms like point-time lock contracts. These are all based on BitVMX ideas. So the source of all this, enlightenment comes from Robin and his ideas with BitVM. But BitVMX is really the only BitVM implementation that currently is robust and cheap and performant. Like BitVM 2 implementation, it only verifies Grok 16 circuits, so it's huge, and it takes like $100K to dispute on chain compared to a few $100 or less than $100 for BitVMX. So it's completely different thing. You have the garbled circuit implementation of BitVMX coming, and I hope this will be in the upcoming month. And I think we are all just scratching the surface of garbled circuits in Bitcoin. Like, there's so many possibilities. So I expect like new innovation happening in the following month. So expect something new happening soon. Okay, that's all. I'm on time. Thank you very much.
So we are going to be taking a break in a moment, but we will do a question or two before we do, and I thoroughly encourage everyone to participate in the BitVMX challenge in the hackathon over the next 3 hours when we're taking a break before returning at 6 p.m. for further talks here. Any questions for Sergio?
Okay. Thank you.
I wish you all lots of luck in the hackathon, and thank you very much to Sergio.
Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now the current is ours. Bitcoin plus Berlin. the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin.
Hello, can you? Yeah, it's clear. Actually, pretty clear. I think you can even hear my breathing, I guess. Thank you. There you go. Okay, so what's up? Bitcoin.
Let's go!
Let's go. All right, so my presentation, it's called User Not Coder. How Lightning feels on the trenches. I even get started with my breathing, sorry. User Not Coder because I work in LA markets. And I'm mostly the community manager over there and also market analyst. But I'm not in the technical side. I'm more on the people side. I always work with all of our traders on a daily basis. Literally daily basis. Or sometimes like 7 from Monday to Sunday. So my plan is to always give LA Markets, to start with this, LA Markets is not in the Lightning business. Like we don't develop on Lightning or we don't work on Lightning directly, although we do some tweaks, we learn about it. But we're in the derivatives, Bitcoin derivatives business. And we use Lightning, so we're also users of it to sell our derivatives to any trader in the world that wants to do some speculation on the price. So we try to make it easy. You make a zap, done, you're in, and you do your trade right away at any time. So I was invited here by Nifty, who literally asked me, I was commenting on on something she was saying about like if Lightning works or not. And then she invited me here to with a question like, does Lightning even works? And I come here with this reply. He said, yes. Okay. I get invited here. I say yes, doesn't elaborate, and leaves. So I'm not going to say that much into that. That's it. It's done. It's done. No, I'm kidding. It does work. It does work for us that we do not like develop directly into Lightning. We are always like developing an infrastructure to provide the best and easiest way for normal traders as well that wants to trade, that wants to speculate with options, with future perps. So Lightning has been a good way to differentiate ourselves from legacy finance. And we're trying to build, we have the goal to build like a non-custodial, purely Bitcoin trading that we're going there. Also, you can check DRCM markets if you want to know more like where we want to go for it. So Lightning has been working well for us. I mean, I know we all know the tweaks we have to do, the trade-offs, and problems that we can have sometimes. But overall, although we have some payment failure rates that we cope with it, we work directly with our users that are like literally 24/7. My payment is not working or whatever they need, and we try to fix it as soon as possible. And we have been like since March 2020, basically doing this every single day. And so far, we haven't been like out of business. We haven't been like down. Even when the times get rough, we still manage to do stuff. We have to implement on-chain lately to also help Lightning as well to offset the peak hours, like when it's needed. But I have a case here that I want to say shout out to the Bolts guys, literally for helping us. There was a time that we were having like almost every day problems with payments getting stuck, like in not even in the node, but like on our server, because our node was getting like full with all the payments requests. And every day, like payments getting stuck and like what's going on. And then the guys at Bolt reach out to us because suddenly, actually, we had a huge influx of users from Brazil, thanks to a Brazilian influencer who found us. He's a Bitcoiner and trader. So we got this massive amount of Brazilians coming into it, and they're using this Aqua Wallet, for example, or other solutions that do swaps, like the Bolt swaps. And the thing is, like, when doing those swaps, the payments were taking like too long to confirm or to do. So we were having all these massive requests for payments. And I was not getting like what was the problem with it, because before was okay. And then the guys at Bolt reach out to us and say like, no, there are some issues that we can help with it. And then we went for it, and there is basically we did 2 tweaks, like the commit intervals and the batch size. Just with these 2 tweaks, basically we have solved the issue of the payments getting stuck. And with that, like literally our users are like so happy with it. And it made me realize that it was like 3 weeks of having problems with the payments. So I was thinking like, I was having like this kind of Twitter or X downs of, does Lightning, it will even work like someday? But then after these tweaks, and the guys were so kind, like to offer these tips to improve. Also on their side, like they were also getting like complaints and so on. And after this, well, users are trading. Like things like came back to their flow. And this made me also realize that Lightning actually does work. Sometimes it requires some cooperation also from some parties, but it makes me see like, okay, these guys from Brazil, for example, they were having other wallets. They use other stuff that need like a submarine swap. And I was seeing in real time, like how Lightning, it's literally like the payment, the payment network or the connective tissue of the Bitcoin network. Okay, I'm getting like a little bit suffocated. Sorry, it's not that nervous. Like I'm talking, and the steam comes in like. Sorry, I mean, I'm saying like that because I'm Anon and so on, so I want to keep it like that, but it requires some extra effort. Like, I can barely see you anyway. So what I wanted to say, that by just doing these 2 tweaks, we solved that issue because one of the things, like, especially like a community manager like me, who's like always like on the trenches, like with them all the time, and to solve their stuff, it gets frustrating when they get like, no, I cannot pay, I cannot do this, and they get very passionate because it's money, it's Bitcoin, it's their Bitcoin, and so on. And then after this tweaks, and I'm using this as an example of what can be done, like I can see in real time that yes, Lightning does work as a payment network. We live on the side like these, like the naysayers. No, like Lightning doesn't work, or like these crypto bros, because it does. At least for us, to help us to in this, in between of what we're trying to build of decentralized, or at least like minimum counterparty risk in trading, for example, that we are dedicated to trading. And Lightning has been a really excellent tool to provide at least instant settlements. They get their trading done, and boom, they get it back into their wallets. So, for example, I wanted to show this tweet. This was in January. This guy, usually because Bitcoin maxis are very passionate about holding and so on. This guy is a Bitcoin maxi, and on Twitter he was one of the ones who was basically telling me all the time, like, if there was a downtown or Lightning was like having some issues, very vocal about it, but like, working with them, with the people, and they see the progress and how Lightning actually, for them now, is like flowing. They even like, we get almost like a free advertisement. The platform is, well, garbage bin. Anyways, if you try us, it's better than X exchange. But that's because we have been like working on it and trying to not stop if a problem comes out. At least, again, like really shout out to the Bolts guy to offer some help on that side. Because me as a community manager, I was getting like the messages, and after that, honestly, has been like very smooth. And I think if we just focus also from now, that it does work, but we have to keep working with a different mindset of, because when I started like crap posting on Twitter, actually that's my real profession, is tweeting 24/7. I thought also like Lightning was like like, like layer 1, but it was layer 2. It's going to be used for everything. I'm going to have like a full node running on my on my phone, and I'm going to do everything. But yes, we have to accept the limitations and combine it. I think of looking for combinations with new stuff like they're doing with ARCs. That's a very interesting proposition. I've myself been reading about it, like also to offer. I'm not a coder, but I would say I'm techie savvy. I know some stuff. I know how these things work. So also reading like to offer ideas to my colleagues to implement stuff and keep working on it. And honestly, I don't know if there. I mean, I also wanted to share that our community is they share a lot. The ones we have in our troll box. Like, for example, if we go here, this is our site. But let's see the price. You see? It's because I'm talking, huh? Cody is talking, 120. Let's LFG. Yeah. You can see, I mean, I'm telling you, like, they're Brazilians. They're even speaking Portuguese here and so on. Like, you can go on your own and see what people speak 24/7. So they're very into talking their minds and how Lightning works. For example, there are some guys who are really new into Bitcoin, and they just started using Lightning with us. And they have found the transition very smooth. Instead of selling them like, no, you have to do a node and so on, some of them, they use Phoenix Wallet, and they just learn how to do the payment to get the liquidity and this stuff. Others prefer, they are more chill, they just want to trade and do the stuff for the culture with the Wall of Satoshi and so on. But I also found that the transition has been like, I've had so many new users into Bitcoin as well and into Lightning that they don't complain, they just see, I want to use the platform to speculate on the price. And they just say, okay, I need to learn this Lightning thing. They learn it, and done. They're set. And well, I would like to know if you want to share, like, with me also, like, actual practical things, or I'll be around also as well to speak about it, about what you have, the feedback you have brought, that you have get from people. Also, I'm happy to share like many stories I've had. I have people who literally speculated on the price. They got their PL or the profit, and they buy, like, I don't know, one guy in Mexico getting tacos for his office for like using Lightning. He won some sats in it, and then he used LNN P2P bot. It's a Telegram bot. To change it for some fiat, and he made it, and he used Lightning all the way. And I mean, it's working. So yeah, to Nifty Nada, she asked me, does Lightning even work? Yes, it does. Thank you so much. Lol. Yeah.
Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin.
100x leverage back.
100x? It's here.
Wait, you guys did that already? Why did nobody tell me?
Man, I mean, literally, like, wait. Like, for the question, I'm going to put it and show it for the question, no?
So this is really, we're scaling Bitcoin degeneracy, like, in real time here.
Yeah,
50x to 100x, let's go.
There you go. 100x. No, do you have any other question?
Any DGens in the audience know?
Like, also, not even a question, like you can, I would love to know if you have any stories like mine, like for example, the guy in Mexico who, I don't think he did 100x, but he did some like 20 or something, and he bought some burritos for his co-workers, or some guys in Brazil also sharing what they do. You can literally see like what they do in real time here, so feel free to also join and speak, and if you have, otherwise, I think we're set.
Let's hear it for Cody. Thank you.
Thank you so much. Thank you so much for having me.
Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run. Forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder.
Gentlemen, up next here on the main stage at Bitcoin Plus, a man who probably needs little introduction, but is leading a company that. Excuse me. There's a conference going on here, guys. There are lovely breakout areas to the side, but if you'd like to join us here at the main stage, we're going to be welcoming Steve Lee, who poached someone from a wizard and is trying to develop more real wizards. So please, a very warm welcome, Steve Lee, head of Spiral. Thank you.
Hey everyone, and yes, Spiral's most notable accomplishment so far is getting Ben Carmen to join. Ben's right in front row. I told Walton that it was a missed opportunity in our introduction tweet. We should have said what he said. Anyway, I'm here to talk about what we can learn from Spark. And let me start with just a little bit of context of who I am. So I work at Block, I lead Spiral, been doing that for 6 years now. We have a team of 15 people working primarily on Lightning Development Kit, but we also have a grant program and funded over a dozen different projects in the space, including Cashew and Fediment. we have an interest in ARC and considering contributing to that. And we've also been building on Spark this year. So I want to, but to be clear, I don't work on Spark, don't work for Lightspark. I'd like to thank Lightspark for answering a lot of my questions, and my own team as well. We've been studying Spark this year to understand it better. I think there's a lot of things to learn from it. And as I mentioned, we've been building on it as well. So it's my sense that the Lightning community maybe doesn't know a whole lot about Spark. So hopefully you learned something today. I'd also like to mention that I'm going to try to get through this in 20 minutes, leave 10 minutes for Q&A. So please make mental notes of any questions you might have for the end. And before I move on, actually let me get a sense for the audience. How many people in the audience have either used a Spark-based wallet or built on Spark to date? Okay, maybe eight or 9 hands raised. That's great. I'm curious, people familiar with Spark, what's your impressions? Who has a favorable impression of Spark technology? Okay, 4.5 hands. Who has an unfavorable impression of Spark? Okay, one hand. All right. Well, so there's a lot of people that probably want to learn. So we'll see what your sentiment is after this. Last spicy question. For those that know anything about it, does anyone in the audience fear that it might become like the Visa of Bitcoin payments? Okay, that has the most hands raised so far. So let's walk through it. So first, my own journey with Spark. So like, again, why am I up here talking about Spark? I don't work for Lightspark. But it dates back, I followed Lightspark from the beginning. They early on began using LDK as part of their solution. So the Spiral team has been supporting them for over 3 years now. And then at the beginning of this year, we started learning more about Spark after it was introduced. I think it was about a year ago. It was introduced. And as we learned about it, it piqued our curiosity because it did seem to solve some of the problems with Lightning and some of the problems that LDK users and our users had been encountering. So we wanted to learn more, see if we could adapt it to Lightning or somehow utilize it. And then we decided to build out a graduated wallet concept, which I think Evan's going to talk about later in this conference, maybe later tonight. And so we hired Ben, and that's his first project. So he's been working on a graduated wallet concept, and so far we built out support for Cashew plus Lightning, as well as Spark plus Lightning. So that gave us some knowledge about what it's like to build on Spark. And then we've done a bunch of looking at the code and studying it, because the documentation online is not necessarily up to date, so you have to look at the code to figure out how it works. So with that context, I'm going to present to you what we've learned. Again, any errors in here are my own. They're not Lightspark's. So what is Spark, at least according to Lightspark, their website? Well, fastest, cheapest, most UX-friendly way to build financial apps and launch assets natively on Bitcoin. And if you go to their website, here's some of the screenshots. The main takeaway here is it can support Bitcoin payments and scaling Bitcoin payments, but it can also be a token platform, issue stablecoins, do DeFi, do all kinds of different things. My personal interest, Spiral's interest in this talk is focused on Bitcoin payments. So we're not, this analysis is focused on Bitcoin payments. So why is Spark interesting? One, I think it's a good recipe. Anyone in the room who's been building on Lightning, or if you have some exposure to Arc or Cashew or any of these different systems, you know that there's a lot of trade-offs that you make, and no one's come up with a silver bullet yet. There's not one solution that checks all the boxes. Spark doesn't check all the boxes either, but I do think it's an interesting recipe. It has good momentum. Definitely taking advantage of the fact, Silicon Valley, like big tech company or California company, heavy on, they've raised a ton of money, heavy on the partnership side, and they've signed up a lot of partnerships, and there's quite a few wallets and financial institutions that are integrating their software. There's also cool aspects to their architecture. They took the state chains model, incorporated that. They have a federated model that they've incorporated. They also use some of the latest technology from like Bitcoin Core with zero-fee commitments. And like Arc, they have payment trees. They also have within their federation distinct roles, which I'll show you in a visual to understand how it, like the Spark server side looks. So let's get into that. So I'm going to walk through a diagram. This here is just starting with a simple representation of the Lightning Network. You can think of the yellow circles as Lightning nodes in the public Lightning Network. And early on, like exchanges like Kraken and River connected to the Lightning Network. Lightspark brought on more fintech companies on the Lightning Network, and there's a bunch of wallets. These are just a sampling of them. Phoenix and Lexi and Alby Hub connect to the Lightning Network. Then we had a number of systems like Cashew and Arc and Fediment get developed. And what's the common thing between all of them? They all connect to the Lightning Network. And the Lightning Network is this beautiful network that creates interoperability between all of these wallets. And users of these wallets don't need to understand any of the complexity shown in this diagram. So Spark, just helping people understand the context and where does it fit in within this, it too connects to the Lightning Network, very much like Arc, Fediment, Cashew. So in this diagram, if we focus in on Spark, the SSP at the bottom, that stands for Spark Service Provider. You can very much think of it as like an LSP, an ASP, or a Lightning Gateway between for Cashew or Fediment. It's the software that's providing liquidity and also swapping between Lightning Network and the Spark system. Above that, there's a box labeled SE that stands for Spark Entity, and within one Spark entity, there can be multiple Spark operators because again, it's a federated model. My understanding, there's currently one entity, Lightspark's entity, and there's two operators within their entity, so it's a 2 of 2 model. My understanding, they do plan to expand and have more operators. The architecture itself supports K of n threshold as well, so it's similar to Fediment in that respect. And then at the top, those are mobile wallets. So Wallet of Satoshi and Blitz and Breeze SDK are 3 publicly announced examples. So just like the other systems, if you're using Wallet of Satoshi with Spark and you want to make a payment to someone using Arc or Lightning, you can do that. And you can also make payments within the Spark entity itself. This here is just a note that in theory you can have multiple Spark entities, just like you can have multiple Cashew mints, multiple Arc servers. That's possible as well with Spark. So I think one confusion is Spark like this proprietary technology from one company, or is it open source? It's a little bit of both. It is the client-side SDK and the Spark operator server software is MIT licensed open source. The SSP code from Lightspark is not yet open source. So if anyone in the room wanted to set up their own entity today, they could do that without permission from Lightspark. You would have to build your own SSP, sort of reverse engineer how to integrate it with an operator. But it's possible, and then you could use the operator code and the client-side code. So if you want to start your own entity, then it's permissionless. If you want to become an operator and join their entity, then you'd have to form a partnership. It's my understanding. If you want to be an SSP though for the entity, I believe that is permissionless because the client wallet connects directly to SSPs and doesn't go through the operator. Last part of the slide, just a quick plug for my own team's software, LDK. As we put the slide together, I guess I was already aware of who's using LDK, but I think just visualizing on one slide is pretty interesting how many edge nodes now are using LDK and has become a sweet spot for LDK usage. Spark uses state chains. And it also uses payment trees. So I'm not going to go through all the details here, but I just want to highlight a few points. On the left-hand side, it says on-chain. So transaction 0 on the left, that's the one transaction that needs to be mined on the blockchain in order to create a payment tree. Then you can have a tree that can be any kind of tree structure. It can be binary tree, quad tree, any different types of depths. But then at the leaves, which are on the right-hand side, those leaves contain off-chain, standard Bitcoin transactions that are off-chain. And those leaves you can think of as coins for someone's wallet. So an individual wallet can be comprised of one or more leaves of one or more trees. There's a lot of overlap and similarities with Arc, but there's definitely differences between the designs as well, how they've approached payment trees. But this, what's important about payment trees, it's a scaling solution. You get to share one UTXO with more users than with Lightning. So you get better economics for that. You can scale better. That's the big win with payment trees. As you'll see on the next slide, there's a cost to payment trees too. There's never a free lunch. So this next slide, Spark payment tree through the lens of one coin. So a bunch of gibberish here. Let's focus in on a few things though. The first thing is on the left-hand side, that oval is representative of the one UTXO that's been that's been mined, that represents the tree. The 4 boxes on the left, those are each branches, nodes in the tree, representing 4 levels deep, and each of those boxes is an off-chain standard Bitcoin transaction. And then these final 3 boxes are is the leaf. So why are the 3 boxes for a leaf? Well, the one on the left, the 65,536 sats, that's the amount of the value that user has in a coin. So why, if that's the leaf, why are the other 2 boxes? That's part of a 2-layer timeout. Because the way that Spark works with their state chains model is that they want to be able to make sure that a previous owner of a coin cannot spend the coin after it's been transferred. So each time there's a payment made on Spark, you decrement the time lock, and at some point you reach 0. And by using a 2-level tree, they get something like 4,000 transfers per payment tree until it expires, and you need to create a new payment tree on chain. So that's beneficial, of course. You get more scaling again, but it creates another couple layers for exiting. And by exiting, this is a diagram of what does it look like if someone wants to unilaterally exit out of the system. Because with Spark, if the operator is operating, then you can just make payments fast, cheap, and easy. But if the operator becomes unresponsive for any reason, and you want to get your money out of the system, there is unilateral exit. But the very important point to make here is, with payment trees, it comes at a high cost. You need to have your own UTXO, which is the other oval, to pay for fees to be able to exit from the system. And then all of the boxes on top are fee bumping transactions, because it uses pay to anchor, which is new in, I think, Bitcoin Core v29, which has a benefit of allowing you to decide on the fees when you want to broadcast as opposed to up front. But it results in over a dozen transactions that you need to publish on chain just to get your value out. So this can work in low fee environments on chain, and it can work for high value coins. But if we're in a high fee environment, then there's going to be a lot of coins that are not economically recoverable. That's one of the trade-offs you get with a system like this that uses payment trees. Arc has similar trade-offs, although I think Arc has a slight advantage on Spark due to some details. Next thing to look at, what do the fees look like in the happy path use case? Like I just make the operator is cooperating and I want to make a payment. There's 4 potential sources for fees. So the first one is theoretical at this point, and that's just fees from the wallet itself. I'm not aware of any wallet. I mean, it's very early days for this. So the wallets that have integrated Spark, they're not charging a fee today. Some might never charge a fee, but there's always the possibility that a wallet wants to make money and they charge a fee. The second one, Spark to Spark fees, that would be the Spark operators charging a fee. And the quote there comes from LightSpark's website, and they state that it's free today with a small flat fee in the future. And then the third source of fees are SSP fees, and that's similar to fees that a Lightning, like a LSP or ASP might charge to do the swapping. And again, the quote there is from LightSpark's website. That's what their SSP charges. But there can be other SSPs, and I believe Breeze has publicly announced that they're going to introduce the SSP in the future as well. So there can be competition there. And then the last potential fee source is the standard Lightning routing fees. Now, you would only incur the bottom three if you're paying someone who's not on the same Spark server or Spark entity as you. If you make a payment to someone on the same Spark entity, then you'd only have the Spark to Spark fees. So analyzing how much it costs and is it cheaper or is it more expensive depends on, you have to model it differently. I'd say overall, though, compared to Lightning, self-custody Lightning, where an individual mobile wallet or a mobile wallet has an individual channel, most use cases, a payment tree-based system like Spark or Arc has economic advantages. So we could spend an hour or more talking about comparing Spark to other technologies. I'm going to try to do it in a minute just to give a taste of it. But I'm going to compare Spark to custodial solutions first. So a huge win with Spark is that there's no KYC. It's the way LightSpark is launching their entity is it's not a licensed money operator, and they're not applying KYC, and they feel like they have a good regulatory story. As I mentioned, it has unilateral exit. There's exceptions to that, but at least it's an option for some users that a custodial solution doesn't provide. And it is relatively a better trust model than a traditional custodial solution. Compared to the Lightning Network, and specifically Lightning Network when you're trying to get it to work for a client, an end user's wallet, it handles low balances really well. It has better economics, as I've already talked about, and at least at this time, it has dependable offline receive. So Spark does support offline receive. It does so through its trust model with all, you have to trust that one of N operators are not going to steal your money. But for mobile phones, that's a big deal. Compared to Arc, and now there's different Arc protocol, or different Arc designs. This is relative to a state chain-based Arc design. As I said, there's a lot of overlap, so they're comparable in many ways. I would say, like for the Arc, there's probably there's some Arc folks here, people interested in Arc. I think the business momentum of LightSpark is a big deal. Needs to be we need to be monitoring that, and if we want to see Arc-based solutions, we need to compete on a business level. And then Spark has a federated state chain model. Arc, I don't believe any of the different Arc implementations have that yet. And that might be a factor in a regulatory story. So that would be a potential advantage with Spark. And then compared to eCash, eCash has a number of advantages, but one big question with eCash is who's going to run the mint? And I think there's dozens of mints right now, but it's more like if you're building a wallet, is there a mint that you believe is going to be around 3 years from now that's going to be dependable? And I don't know if, I think the answer is no to that right now. Hopefully that changes and evolves over time. But at least with Spark, you're pointing to LightSpark, or you can create your own. And again, unilateral exit, and it's an interesting debate and discussion, but arguably a better trust model as well, because you're not, as long as the state chain model of Spark, you're deleting the keys, then you can't, the entity or the operators can't steal the money. So it's not all roses, though. So what are some of the drawbacks and risks of Spark? One, as mentioned, it uses state chains, and state chains. The great thing about state chains is you can do off-chain transfers of UTXOs. that comes with a cost. You're trusting the operator to delete keys. And in this case, a federation of operators, and where at least one has to delete the keys. If they don't, then they can collude with the previous owner and steal the money. So even if you trust Lightspark to be a good actor and not do that, which is, I think, a reasonable assumption that they wouldn't, you're still not protected from a hacker hacking into the system or a rogue employee changing the code so that it does not delete the keys unbeknownst to Lightspark, and then for that window of time where that's occurring, all that money could be stolen. The other risk with a model like this is government intervention. Like if some government, some jurisdiction doesn't like the fact that they're not KYCing users, they could knock on their door and say, hey, we want to freeze funds until you take action. Now, the freezing of funds, I say some funds because, again, they do have a unilateral exit. So for funds that can economically exit, then those aren't at risk. But for low balance wallets, those funds would be at risk of freezing. Another risk is centralization. So if Lightspark is the only Spark entity 5 years from now and it becomes super popular, that's I asked at the beginning who thinks it might become Visa. That would be one element of it becoming Visa if it's the only Spark entity. Lack of privacy, and this is something. So something I learned recently, which kind of surprised me, is that all the transaction data done on the Lightspark's entity is intentionally published. So it's public data. So it's much like the layer 1 Bitcoin blockchain, in which every transaction you do is public. And they also currently don't have what they call dynamic addresses. So you reuse an address. So basically your Spark address is effectively your wallet. And in fact, I have a Blitz wallet on my phone. I grabbed the Spark address from it, plugged it into SparkScan, which is a website, much like a Ethereum Explorer. And sure enough, I saw my balance. I saw every transaction I've ever done on my mobile wallet. So I was pretty surprised by that. When I inquired, it's not a technology limitation, but it's an intentional policy decision by their entity. I can't steel man the argument. They feel like it's disingenuous to users to not publish it because of the risk of a Spark operator potentially publishing it. I don't think it's a good decision, but that's what it currently is. The good news is if anyone wants to create their own Spark entity, they can have a different policy and not publish the data. Now, everyone's transactions are still known to the operators, so that would put it on par with like using Visa or a bank or Cash App or something like that. But making it public, I don't think it's equivalent to layer 1, because if such a system became popular for daily payments, I think people's daily payments tell a story about themselves very differently than making a few Bitcoin purchases and putting it in cold storage. So I think it's a different privacy profile. And the last drawback to point out is just censorship resistance. If you want to make a payment, at least a small payment, you're beholden to the server agreeing to it. Again, you can unilaterally exit, but it's not as censorship resistant as like Lightning, let alone on-chain. So last thing, what are some potential improvements? One, as I've alluded to, more Spark entities that'd be healthier for the Bitcoin network. You can get more competition, different policies, different fees, etc. Privacy improvements. So one thing that Lightspark has publicly stated is that they, by the end of the year, they intend to introduce dynamic addresses, which basically eliminates the need to reuse addresses on Spark. But again, the data would still be all public. Bolt 12 and BIP 353 support. I think that's super important that all these different systems support that, and we now have Cashew supporting it, Fedimint supporting sending Bolt 12s. Many Lightning wallets now support it. So going back to that graphic that showed all the different wallets and systems connecting the Lightning network, Bolt 12 and BIP 353 can be the standard language or payment protocol between all of them. when we studied some of the client-side SDK, a wallet on a phone has to make a lot of different connections to a lot of different servers. That can be optimized over time. Otherwise, I'd worry a little bit about latency for payments. Open source developer community engagement. I think they've done, Lightspark has done a decent job, but could certainly do better. There's exploration by them, and also the Spiral team has discussed it as well. Can a trusted execution environment help improve the trust model? The current conclusion is that it might make a practical step in the right direction, but it would not fundamentally make the system trustless. And the last thing, anyone familiar with state chains and the trust model, one attack vector with a state chain model is that a state chain operator can fork the state chain and lie to clients, but to protect against that, you could produce a public proof that proves they're not doing that. So takeaways, one, Spark has momentum. Pay attention, don't sleep on it. It has leveled up the mobile UX, and so especially for people that have been building on Lightning for a long time, Spiral has a lot of exposure to that. It's good. It creates competition. It's good to set that higher watermark, and for other systems to beat and exceed that. But there are a number of drawbacks to Spark. Again, there's no silver bullet, some of which can be mitigated over time. And last thing I'll leave you with is, so how should we respond to Spark? Should we adopt it? Should we contribute to it? Can we make Lightning better, Arc better, etc.? That's all I have. So open to questions, though.
Thank you. Great summary. I have a question about the potential improvements. Like I've read from the Blitz wallet developer that the one payment takes like about 6 to 8 seconds, which is like certainly much higher than a typical Lightning payment. And how difficult is it to scale the infrastructure? Like, are we talking about building a data center, or just needs like a few more CPUs?
Yeah. I can only speculate. I don't know the answer. I've definitely observed that myself when I've used Blitz, and other people have used Wallet of Satoshi and reported seeing pretty bad delays on payment latency. With what I understand of the architecture, I don't see any fundamental reason it should be slow. It could be, the client-side latency I mentioned. That's one source of potential latency, and that might explain some of it, or maybe a lot of it. So I believe for that one, Lightspark's planning on, improving that. But I don't know the profiling of it to know all the different components for why it's slow. But it's my sense that I don't think that's like a fundamental limitation. I would expect it to be addressed, in the next year or so.
Let's hear it for Steve. Thank you.
The city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus...
Gentlemen, please give a very warm welcome to Tyler Wood, running the block Lightning node.
Yeah. All right. Thanks, everyone. As you mentioned, my name is Tyler Wood, and I'm going to be talking about running the block Lightning node tonight. A little bit about myself. I'm a data scientist on the Bitcoin team at Block. I was an early team member at C equals, which was the block Lightning team. And I'm the team lead for the C equals braid, which is the node automation service that I'll be talking a little about today. I've been a personal Lightning node runner since about 2020, so that's how I learned a lot about this stuff. And I used to run a website called bitcoinkpis.com that had like a lot of fun metrics about Lightning Network and coin joins and stuff. So yeah, I really love Bitcoin, Bitcoin data, Lightning Network, all that stuff. The block Lightning node, it was the node that is formerly known as C equals. We recently renamed it to just block. So I'll be referring to it as block throughout this presentation, but you can just kind of think of it as the C equals node that you might be familiar with. That node is an LDK-based routing node that we run, and it serves as the gateway for Block's Lightning services. So that would include Cash App, where we have a lot of users who are making Lightning payments outbound, Square, which we are launching soon, which will have a lot of merchants hopefully accepting Bitcoin payments for goods and services. And there's a few other, Lightning things that we could apply the Block node for that we hope to do in the future. Block runs one of the top Lightning nodes globally, and there are 50 million monthly Cash App users who have access to sending payments through this node. Over the past year, we've seen 600% growth in the number of Lightning payments these people are doing. So that's a 7x year over year. So the activity is really exploding. And at this point, 1 in 4 of our outbound Bitcoin payments are using Lightning, with the other 75% being on-chain. And that's a ratio that has really grown over the past year, as that's grown over 700%. So we're really proud of those metrics, a lot of people using this node. So what I mentioned earlier, we have this service called the Node Brain, which is what I'm going to be talking about today. And that's the service that is deciding what actions to take for the node. So a little bit more operational. The Node Brain is the automation layer for managing liquidity and node operations for the block Lightning node. The goal of this service is to maximize payment reliability for our internal customers, which is what we refer to Cash App and Square as, and for potential future external customers, which would be customers of an open LSP. Anything else is incidental to our goal of just providing the best payment experience. So having really high payment reliability, fast payments, that kind of stuff. For our direct customers, we're definitely not like maximizing yield or anything like that. The goal is high payment reliability for our customers. A little bit about the architecture of this system. So a lot of this stuff is kind of default block infrastructure. It's like an enterprise stack, but I think that a lot of the functionality could be replicated with more accessible components and tools. And so the first thing that we use heavily is Snowflake, which is a cloud kind of SQL engine. And we have the node push a bunch of data into Snowflake, and then we pull from that data when we want to take actions. So we have like 2 years worth of historical data in Snowflake about all of our payments, about our channel balances over time, what channels we've had, what fee rates we've had, what the payment flows were at specific fee rates. And having this historical data is super important, and that kind of fuels all the decisions that we make. So we have all that data in Snowflake, and then we have this next layer, which is built on Prefect. So Snowflake and Prefect are both things that are used heavily within Block. They're kind of default infrastructure and well supported by our internal teams. And so that's the reason that we kind of built on these things. And Prefect is just a workflow orchestration tool. You can imagine it as just a way to like schedule a job. And so we have these jobs that we write and we put them in prefect, and these jobs basically run on a schedule, and they'll pull data from Snowflake, kind of look at that data, apply some heuristics, make a decision, and then that decision the brain, which runs on prefect, is pushing these actions. And then we have a thing on the node side that we call the automation proxy, and that is reading from the queue and then taking actions on our node. And it's also applying some rate limits and stuff like that on the node side, just to make sure that like the stuff that I'm writing isn't going to tell our node to like close all of our channels or do something really stupid. So kind of preventing foot guns there. I want to talk about some of the core concepts and kind of like tools that we use to help drive decisions for our node. The first one that we use a lot is just looking at fee rate distributions for nodes. So what we have here is kind of like a CDF of the channel capacity for two nodes, and it's showing basically what percentage of their channel capacity exists at a certain fee rate. So we have the block node, which is our node, is going to be the red line. And I'm comparing it here to loop, which is going to be the green line, just using loop as like the canonical example of a really high fee rate node. And so the way to read this is basically like, if you were to go here, 20th percentile, that would say that 20% of the channel value that's pointed towards the block node has essentially a 0 ppm fee rate. Whereas for loop, that value is going to be like 1700 ppm or something like that. So the 20th percentile for loop is super high. And then the median for these, for block, it's 150 ppm, and for loop, it's 2950, et cetera. And then you can see they kind of both go up as the percentiles get higher. But the way we use this is we will use it to kind of get a sense of like market pricing for liquidity to a certain node, basically. And you can kind of use it so that like, let's say maybe you want to set it at like 40 or 50%, and then as kind of that market evolves around that node, you will kind of still have like a consistent pricing and position there. And then also it's going to be really resistant to outliers. So like you can basically imagine that if you just chop off like the tails, it's not going to be really influenced by this like long tail of 0 ppm or this crazy long tail for loop that's at like 8,000 ppm. And if you were to do like an average fee rate, you're going to be really susceptible to those long tails. So I really like this kind of construct as a way of looking at the market rate for liquidity to a certain node. The next tool that I'm going to talk about is something called Flux. Not the sponsor of the conference, but good name. So Flux is something I think was originally invented by maybe Nick Slaney, who worked with us at C equals, or maybe it was external, I don't know. He was the first person that told me about it. But basically, the idea of Flux is that it's a kind of like a velocity measurement. And so Flux is going to be the net payment flow over a channel or peer per unit time, and that's going to be at a specific fee rate. And so positive flux is going to be when a node is a source, so they're going to be originating more payments than they are receiving. And negative flux is going to be the opposite of that. That's going to be when the peer or channel is a sink and they're receiving more payments than they're originating. And I have kind of this like idealized version of a flux curve over here to the left. It's like a fake curve. It would never be that smooth. There'd be like crazy discontinuities. But it kind of gives you the general relationship that we're trying to measure here. So like when the fee rate is 0 ppm, that's a 0 fee. So you would expect a lot of liquidity to move over that channel. So it's going to have a high negative value and be a sink. As you kind of raise the fee rate, maybe you can imagine that you have like a valve that's completely open, and you're kind of gradually like closing that valve. And so the flux is going to get kind of throttled a little bit. And then eventually it will hit some point where it's 0. And when it's at 0, that either means that no payments are flowing through the channel or the flows are perfectly balanced. Either way, for you as a node runner, that channel is going to not really need additional liquidity kind of in average. And then you can imagine that there might be a crossover point where like if you raise the fee to an absurd level, you're kind of closing off that valve in one direction, and then you're not going to get any downstream traffic, and only that channel is only going to act as a sink, and that's when it might turn to be positive flux. So that's kind of an idealized relationship there. I don't think it really exists that cleanly in reality. but it's kind of an interesting tool that we use to evaluate our node's liquidity state and balance source and sink channels. Also, we can use this like historical flux data to forecast the lifetime of a channel of a given size to a certain destination with a certain fee rate. And then the last kind of concept here is that you can kind of actively manage flux by adjusting fees. This last one kind of combines some of the stuff on the previous slide about flux. But basically, for nodes that we don't have historical data on, we might want to try to have some kind of prior on how they might act before we create a channel to them. So in that case, we'd want to know, are they going to be a source or are they going to be a sink? So we can set the right fee rate to them ahead of time, and we don't like create a channel and then it suddenly gets all the liquidity stolen. And to do this, we did some clustering based on the public graph data. So stuff that's all publicly available from the Lightning graph. And it was just using like four inputs, which were the node's public capacity, the node's channel count, the inbound fee distribution, which is kind of the thing that I just showed, but we would just choose like the median value, and then the outbound fee distribution, which is kind of the opposite of that. It's like, what are the node's outbound fees? And just using those four signals, you can kind of throw them into this dimensionality reduction algorithm, and that takes a 4-dimensional data set and it collapses it into this 2-dimensional scatter plot that you see. And then you can already there see some groupings. And basically what the clustering is doing is like, if I just picked someone out of the crowd and was like, circle the different groups of dots in this thing. And then once you have those clusters, you can look at the nodes in those clusters and think, these have similar characteristics, and if they've had similar flux values in the past, then the ones in that cluster that don't have historical data, you can kind of project how they might act in the future. So that's a cool tool that we use to like infer some stuff about a node if we've never seen it before. So those are some of the core tools that we use, and we use those to fuel our automations, which are the actions that the node takes over time. And so with a name like the brain, you might be thinking like, oh, they probably use like AI or reinforcement learning or something. Just use very simple heuristics. So we have Drake here. He's saying 4 heuristics. That's all you need. And I'll be going over each of these heuristics and telling you kind of how they operate. And that's basically how the node is run. Super simple. The first one we call replenish liquidity. And basically the purpose of it is to open new channels to maintain send capacity to top destinations when the capacity is too low. We don't do rebalancing, so we do a lot of channel opening and closing, which is a little bit wasteful. So don't yell at me. The way this works is we have a job that uses our historical data to identify top payment destinations, top routers on the network, and then some priority channel partners. And that's the set of peers that we want to maintain constant send capacity to. We use the flux tool that we talked about earlier to calculate an optimal channel size. So basically we use flux, that's the rate of channel depletion over time, and we say, let's create a channel that we expect to last 2 days. That gives us a channel size, then we have that target channel size, and then we basically just have this glorified cron job that's just checking, and it's saying like, if the balance falls below 25% of that target channel size, just open a new channel. And so that's how we decide how to open our channels. The next one is fee setting. And this is, again, another important thing because we need to set the right fees so that we can protect our liquidity for our internal and external customers, and so it doesn't get like stolen by arbitrage bots. The way this one works is we have that categorization of nodes into source, neutral, or sink. That's either based on the clustering, or if we have historical data, we just use that. And then we just applied differential fee rates for those different tiers. So the source nodes are going to get like a low flat fee. And the idea there is that we want those channels to route in the kind of sink direction because that's like free passive rebalancing. So we just keep a low fee for those channels. That worked great. For neutral nodes, we kind of choose like a mid-market fee rate. So using those distributions, maybe we'd choose something in the range of like 30 to 50 percentile. And then for sync nodes, we just choose a high distribution fee rate. And again, those distributions are going to be tailored for each of the peers themselves. So like a high distribution fee is going to be higher for a sync node than it would be for a neutral node. But yeah, again, for sync nodes, we apply the high distribution fee rate, and that's going to be somewhere between like 60th to 70th percentile. Yeah, and that's what we do for fee setting. The next one is closing unproductive channels. So it's kind of just like deciding when to reallocate some of our liquidity. This one closes channels that aren't being used effectively to free up capital for more productive channels. And the logic here, again, is really simple. It looks for channels that we have opened, so outbound channels. The idea there is that we don't want to close inbound channels, which are channels that other people on the network have like used their money to deploy to open to us. They paid the fee rate, and it would be like not cool of us if we just closed it for no reason because it's their channel. So we only really close the outbound channels. And then we just check to see if that channel has routed some critical threshold of capacity over some trailing day period. So you can imagine it would be something like, has this channel routed 10% of its capacity over the last 30 days or something? A really simple heuristic, and it just kind of checks that. And if it is not kind of meeting that bar, then we'll close that channel and take those funds and deploy them elsewhere. Yeah, and again, because we have this kind of trailing concept where it's like the past 28 days, we're going to wait till we have like a full 28 days of history on that channel before we would make that decision as well as kind of a check. This is the last of the 4 heuristics that we have, which is just harvest UTXOs. Apologies for the ChatGPT slop here, but I generated one of these for each of the capabilities, and this was the only one that I actually liked, so I kept it in there. And this one, again, it's super simple. We tend to end up with like a lot of duplicate channels because, like I mentioned, we don't really do the rebalancing. So we're just kind of like opening channels again and again, and so we can have them accumulate. And this one just looks for peers where we have multiple channels with them, and then it kind of decides to keep 2 channels. One would be the best sending channel, which is going to have the highest local balance. The other is going to be the best receiving channel, highest remote balance. And then it's just going to close all the other channels and grab those sweet UTXOs. We tend with this one to target channels with a high local balance because we're trying to accumulate more Bitcoin to deploy elsewhere, and those are going to be like the best bang for your buck, the ones with a high local balance. The channels that have like a super high remote balance or almost all remote balance, we tend not to close those actively ourselves because kind of philosophically, I believe like that's the peer and the channel's money for the most part, and they can decide to close it when they want to. And it's not like up to me to make that decision necessarily. So yeah, that's the last of the kind of 4 heuristics that we use to govern the node. All super simple. I think all stuff that people could probably replicate if they wanted to. And that takes care of a lot of the maintenance for the node. There's definitely like a little bit of manual stuff, and I tend to like watch the node like a hawk. Like I have a bunch of dashboards and I look at them every day and I know all the top peers and the flow rates and all that stuff, but I don't intervene very much anymore. Like I think most of the stuff we built kind of runs self-sustaining, which is great. That's what you want. So that's how the node runs. I'm going to talk a little bit now about some of the liquidity dynamics that are created by some of the kind of internal customers that we have. So as a kind of primer on inbound versus outbound liquidity, who here kind of understands what inbound liquidity is on Lightning Network? Raise your hand. Okay, cool. So that's most people. So I won't go too deep into what inbound is, but here I have an example of like kind of like an idealized 4-node Lightning Network. So we have Cash App on the bottom left. We have the block node kind of in the middle, the blue one. We have like Alice node on the right, and we have Square up on the top. And then we have these little kind of orbs of Bitcoin representing a channel or a balance in a channel. And the idea here is that Cash App is a very heavy net sender of Bitcoin on the Lightning Network. So the Cash App users are sending way more than they're receiving, and this pattern creates consistent inbound liquidity with the peers of the block node. So in the first diagram, you can see that the balance is on the side of Cash App in that channel, and then on these two channels, it's on the side of the block node. And then it undergoes this transition where all of the Cash App users have decided to pay the Alice node. So by paying the Alice node, it's created this new liquidity situation where the balance in the Cash App to block channel is on the block side, and now the balance in the block to Alice channel is on the Alice side. And that has created inbound liquidity for the block node with the Alice node. And so what this does is it is what I call the inbound generation engine. So the inbound liquidity generated by Cash App builds up like a stock of unused inventory that can be utilized to help merchants like Square receive Lightning payments. And so in this set of transitions, we're going from the last state on the previous slide where the inbound is at the Alice node, and now we're visualizing how that inbound can be used to help Square or other merchants like Square or other actors on the Lightning Network receive payments. And so now if people using the Alice node want to pay Square, they have the liquidity at C equals already. And so we can facilitate that payment without paying somebody to acquire inbound or doing a loop out or doing any kind of liquidity action or something like that. And so this constant activity by the Cash App users is generating this inbound. It's a valuable commodity on the Lightning Network, and you can repurpose that to help a business like Square that's a net recipient of liquidity. And so that's kind of the main liquidity dynamic that's occurring on our node, and it's a really kind of powerful, interesting thing. So some of the implications of this type of liquidity dynamic that we've kind of learned by operating here is that wallets with a strong net sending activity will naturally generate inbound liquidity, and this kind of creates a native monetization opportunity. And this opportunity is not proportional, or it is proportional to the net payment volume of the wallet, and it's not proportional to the deployed Bitcoin capacity. So I wouldn't think of it like a yield where it's like, maybe we can put more Bitcoin into the node and then we can generate more kind of routing revenue from that inbound liquidity. No, the activity and the value here is in proportion to how much payment activity is happening with Cash App. And so you might think about like what are other examples of kind of net sending wallets that might act like Cash App in this case. They would tend to be probably mostly consumer wallets, not merchants. And maybe wallets where people don't onboard by like receiving Lightning as their first payment. So that would be something that might negate some kind of later net sending there. Another implication here is that routing revenue emerges from proximity to genuine economic activity, not financial engineering or outsmarting other routing nodes. We're not like Flash Boys. We're not trying to play liquidity games. Our node automations are super simple. I kind of call them like proudly left curve, honestly. There's no free lunch with Bitcoin yield. You have to create value for other people on the network, and creating value is hard. And real payments are something that creates a lot of utility for people. So being a node that's close to real payments, I think, is going to be a sustainable way for you to like generate value. Which leads me into the last conclusion here. So it's all about real payments for goods and services and not about routing games and yield? No. Let's focus on growing the Lightning economy through building services that will facilitate real payments for people. When we talked a little bit about some of our nodes kind of performance and stuff like that, some people wanted to know like how can we scale this routing revenue? Can we like put more Bitcoin on the node? Like that's not going to work for the reason I mentioned earlier. Like you need to, the value here is created in proportion to the amount of sending activity on Cash App. Can we like increase how much routing activity comes through the block node? I mean, you could, but like the much bigger way to grow this activity is just to like grow the Lightning economy by like an order of magnitude. And that's totally what we're focused on at Block, building these products. So that leads me into my final slide, which just says that's what we're trying to do with Bitcoin payments on Square. We hope that that can grow the Lightning economy and benefit everyone operating on the Lightning Network and everyone here who's building on it. End of my talk. Thank you.
Yeah, great talk. Thanks a lot. Do you plan to make it like make C equals like an open LSP, also serving other wallets beyond Cash App?
I think we would love to do that at some point, but there are factors beyond my pay grade that, yeah.
Great talk, thank you. When you look at the fee distributions, do you just do this on a per node level, or do you also look at the global fee distributions in the network and take this into considerations when making decisions?
Yeah, that's interesting. I've only looked at it per node because we're generally making these decisions for the fee for that node, but it would be kind of interesting, like you mentioned, to like look and see how much of an outlier a specific node is compared to kind of the pack. So yeah, that would be a great suggestion.
All right. Sorry to hit you with a double whammy, but first question, are you thinking at all in the long term about kind of closing the loop in terms of Square merchants who want to sell going back through Cash App? And then two, have you kind of thought at all in terms of how you manage the whole fee rate structure here in a more mature on-chain fee market, like especially considering the channel opening and closing strategy that you guys employ?
Could you clarify what you mean by the first one, closing the loop with Square and Cash App?
Kind of the way you have Cash App generating inbound liquidity to the external network that Square merchants can take advantage of, like allow them to organically rebalance, like going back through the Cash App node if they want to exit to fiat?
Maybe I don't understand, but when Cash App users would pay Square in this model, they're just going through the block nodes. So they're not necessarily touching the external network. So they're not going to be creating nor consuming that inbound. It's only with the interactions with the external network. But yeah, Square merchants will be able to do things with their Bitcoin after they receive it. And the second one, thinking about how we do liquidity actions in a more mature market. Yeah, I think that, for example, we have Z-Man on the team, and he has these ideas around like forwardable peer swaps and stuff like that that I think sound like a really cool way to scale a rebalance action into like one single on-chain thing. I don't think that those ideas are very mature inside of our own team, so I think that's a little far off for us. But I think there's some cool ideas there, for sure.
Thank you very much. Let's hear it for Tyler.
Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin. Berlin, the city where walls fell and freedom rose. This storm is more than thunder, it's code, alive, unstoppable. Through rain and shadows we run, forged by fire, forged by freedom. Because now, the current is ours. Bitcoin plus Berlin.
The final piece of content here on the main stage on the first day at Bitcoin Plus. We have a mini panel for you, unlocking Bitcoin payments with open standard. The panel is going to be moderated by Moritz from Alby. Please give a very warm welcome to Moritz, who will then be introducing his panelists. Moritz, welcome.
Cool. Yo,
I'm actually pretty surprised, like positively. There's still so many people here, and I can only contribute that like it must be a super awesome day, and of course also to the guest of this panel here. Yeah, so the topic is unlocking Bitcoin payments with open standards, because if we look at Lightning today, so we have payment rails that are instant, that are globally, that are low cost. And if we add also the capability of like permissionless payments, then I think there's one category of use cases that stands out where there's a great fit, which is payments in apps, payments between apps and users, and as we have already learned today, this afternoon, also payments between even autonomous agents, for example, right? But if we look at the ecosystem today, then there are like roughly 40 Lightning wallets, and there are roughly 40, 50 real good Bitcoin Lightning apps, right? So, and if you look at other ecosystems, so recent numbers, for example, from DAppRadar, show there are 4,000 active dApps on Ethereum today. Like that's 100 times more than the number of Bitcoin apps. You can say, okay, payments is just a subcategory there, but it's a different scale, right? And I think one thing that contributed to this growth in other ecosystems are open standards like Wallet Connect or EIP 1193, for example. And in Bitcoin and the Lightning ecosystem, we actually have similar open standards. It started with WebLN from Joule, for example, LNC, and since 2 years also Nostr Wallet Connect. And yeah, I'm super happy now that I can welcome Evan from Zeus here to the panel and EK from Second News, who will talk about their experience building on these open standards. So yeah, big applause to them.
All right.
Cool. Yeah, for the start, can you just introduce yourself and what are you building?
So, hi, I'm EK from Stacker News, and we're building something like Reddit, but with Bitcoin. And we're using Nostr Wallet Connect, so you can bring your own wallet like Zeus. Okay.
Hey all, my name is Evan Kaludis. I'm the founder of Zeus. It's primarily a self-custodial Lightning wallet, and it's got NWC built into it.
And why did you do that? And which other like open standards did you actually explore that are similar to Nostr Wallet?
Oh man,
Connect?
so Zeus first and foremost started as a remote connection app. So being able to get to your Lightning node has had its challenges over the years since we built this thing starting in 2019. So you either had to have your node hosted up in a cloud service where you could hit it over ClearNet, or you had to have Tor set up, and everyone knows how unreliable Tor can be if you've worked with it long enough. So we had a lot of nightmare cases there with the user saying, your app's broken, I can't connect. It's like, no, it's just Tor. We implemented some other connection methods like Lightning Node Connect, which is for LND nodes that the Lightning Labs team built, which is great when it works. It's really fully featured, but it can be a little finicky at times. And yeah, Nostr Wallet Connect has been like a really great one that we implemented it as more platforms, especially as Alby Hub went and implemented and championed it. And just been working fantastic. It might not be as fully featured as some other connection methods, but it's snappy, it's reliable, and it's powerful, especially as the ecosystem, the apps that support it grows. So we're super excited right now. Today you can use it as a client. So if your node has Nostr Wallet Connect on it, like an Alby Hub node, you can use Zeus as the remote controller for it. But in a near future release of Zeus, you're also going to be able to use it the other way around, where you're going to be able to connect your Zeus wallet remotely to other NWC applications. For example, you'll be able to take your Zeus wallet and connect it directly to a Damus or an Amethyst and start zapping with your Zeus balance directly to those apps. So we're super excited about that.
Cool. What problem does like if we look at the wallet use case where like sort of Zeus acts as the NWC server. What problem does an open standard like NWC solve for you in this case, or especially for your users?
Well, you know, making that connection to your node, it's tricky, right? So your node is either exposed to the clearnet, which is not great, especially if you're hosting it at home and you have a router, like total security nightmare. You're dealing with unreliable connection methods like Tor. You're either, in other cases, you could be using something like a WireGuard sort of VPN, which sort of some might consider network malware. And for us, Nostr Wallet Connect just made sense. Like, we're already talking on Nostr for these other interactions on our wallet. Like, we use it for these attestations, for our somewhat controversial Zap Blocker Lightning address implementation, but also for contacts in Nostr. And we were just seeing all these different ways that Nostr was turbocharging our wallet and adding this new functionality. So we already had the tools to talk on Nostr, and just adding the connection method was a no-brainer. No added dependencies, really good security, and works reliably, which is the most important part. So sort of a perfect fix, yeah.
That's like but the wallet perspective. So you're more like the app perspective that you can bring in. Like, why did you? I think you also did try WebLN, LNC, Nostr Wallet Connect. Like, what's your learning there?
Yeah, I can definitely say Nostr Wallet Connect was simpler than Lightning Node Connect, also because it's not limited to LND. So you can wrap anything with Nostr Wallet Connect. And specifically with Lightning Node Connect, I noticed that if you have like multiple tabs open, then they try to reuse the connection, and there are some issues with that. Like also like users reported issues. So for us, it's like an easier way to get wallets from wherever they are hosted, like mobile, like Zeus, to make payments without us, like without being custodial. Like, so we don't have to like have our own wallet. We can just tell users here, if your wallet supports Nostr Wallet Connect, you can just connect via that.
And why is it important for you, like, to not touch user funds?
Yeah, we don't want to touch user funds because that would make us custodial and liable, like not only laws or regulation, also like when we get hacked or something. Like, we just don't want to deal with that if we don't have to.
And what was a big challenge for you, like when you integrated these open standards, like from a developer perspective, like also maybe for other people who build on these standards, can you give them some advice?
Yes. Yeah, I can definitely recommend reading the spec properly. I remember when it was very early, Nostr Wallet Connect just came out. Everybody was really excited, like it's still exciting. But at the time, I think I just looked at other implementations and I was like, okay, I got it. And then later, when we were testing with more wallets, I think I was just testing with Alby at the time. Ben the Carman had to show me, hey, you split the permission string by space, not by some other character. And that's why it failed to connect with Mutiny Wallet. But there was like small issues like that. Like, you can easily solve them just by making sure you implement the spec properly. But also with other, like when someone else already implemented the spec, like it's easy to just also support their tiny little thing. So does that make sense?
Yeah, sure. Well, maybe a question to you, to both of you, like where do users actually struggle to use this way of using apps and wallets?
Yeah, maybe that was specific to our use case, because we also want